Hey guys! Tonight we're going to travel back to a world long before our own, a world ruled by giants you've never heard of, and we're going to watch it drown. Imagine you are standing in a desert, hotter and vaster than the Sahara. You are in the heart of Pangea, 235 million years ago. The air is dry, the rock is rust red, and the silence is absolute. You dig down, past the red dust, and you hit something impossible. A thick, black, oily band of shale. A scar of rock that screams of deep water, of swamps and rot buried in the middle of a desert wasteland. This black line exists all over the world. It marks a moment when the entire planet's climate system broke. A time when a fiery apocalypse triggered an endless flood, wiping out the dominant empires of life and clearing the stage. What could possibly cause the entire world to flood? How could it rain, not for a week or a year, but for 2 million years straight? And what does this ancient catastrophe have to do with the rise of the most famous creatures of all time? The dinosaurs. Thanks to the patient work of geologists chipping away at this very mystery, we can now piece together the story. Tonight, we will solve the mystery of the Black Scar and witness the birth of a new age. Frankly, if you were dropped here without a submersible, you wouldn't survive a single second to realize where you went wrong. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. That small click sends a big signal to the algorithm. That long-form, serious educational content still matters. And to me, it's an incredibly meaningful show of support. Thank you so much for helping keep this channel going strong. It always fascinates me to see where you're all tuning in from. Let me know in the comments where you are in the world and what time it is for you. Now, dim the lights. Maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You are on that supercontinent, Pangea. It's important to grasp just how alien this is. This isn't just a big land mass. It's practically the only land mass. Forget the 7 continents you know. This is one enormous, lonely slab of rock stretching from the North Pole to the South Pole. You could, in theory, walk from Antarctica to Alaska, assuming you had a lot of snacks and a very high tolerance for boredom. There is no Atlantic Ocean to stop you. There is no Pacific. Not really. Just one truly planet-spanning ocean called Panthalassa. This single massive continent is so large that it doesn't just have a climate, it creates its own, and the rules are brutal. The coasts, thousands of kilometers away from where you stand, are humid and battered by storms. But here, in the deep interior, you are in a prison of your own geography. The ocean-borne moisture simply can't reach you. You are in the driest place this planet has ever known. The climate is one of violent extremes, a mega monsoon system. Forget our 4 gentle seasons. Pangea's world is defined by 2, a bone-dry dry season that lasts for most of the year, and a terrifyingly violent wet season. Right now, you are in the dry season. The sun is a white-hot enemy in a brassy sky. The air is thin and sharp. Global temperatures, as a baseline, are already several degrees hotter than our modern world. This is a hothouse planet. There are no polar ice caps, no great shields of white to reflect sunlight back into space. The planet just sits and bakes. You feel the heat not just on your skin, but radiating back up from the ground, a convection oven effect that shimmers the air. You look out, and the landscape is a spectrum of reds: deep rust, burnt orange, pale, dusty pink. This isn't just a color. It's a chemical signature. This is the scientific evidence for an ancient arid world. The rock itself is a red bed, a geological formation where the iron minerals in the soil have literally oxidized. They've rusted, like a piece of metal left out in the air. This process can only happen over vast, dry timescales. You are standing on a continent of rust. You're desperate for water, so you look for a river. You find one, but it's a ghost. It's just a wide, sandy, braided channel of cracked mud and dust. These are ephemeral rivers. They are spectral memories of water, and for most of the year, they are just dusty highways. Life doesn't cluster around the riverbanks, as it does in our world. It clusters around the hope of a river, hunkering down in burrows or tough, waxy-leaved plants, just waiting. Scholars still argue about the precise mechanics of these mega-monsoons. Some models suggest a single, colossal pulse of rain that sweeps across the entire continent. Others suggest a more chaotic, shifting pattern of regional deluges. But all agree on the outcome. The sheer size of Pangea meant that when the wet season did arrive, it was unimaginably violent. It wasn't a gentle rain, it was a continental-scale flood, dumping a year's worth of water in a matter of weeks, a deluge that would tear through these dry riverbeds and reshape the land before vanishing again. This is the world you're in. It is a world of blazing, arid extremes. And the flora has adapted to it. You don't see lush jungles or grassy plains. You see tough, scattered stands of shrubs and trees. The dominant plants, the foundation of this ecosystem, are the seed ferns. They aren't the delicate spore-bearing ferns you might have in your house. They are a rugged, extinct group of plants that evolved seeds, a critical adaptation that let them endure this brutal cycle of drought and flood. They are the tough, resilient bedrock of this very, very dry world. You trudge through this dry, red dust, surrounded by these tough seed ferns, and you have to recalibrate your brain. Our modern bias is to see a desert as a wasteland, a place that is broken or empty. But this world you're in, it works. It is a roaring, thrumming, successful ecosystem. It is not a wasteland. It is a finely tuned, stable machine that has been running with variations for tens of millions of years. This is normal. The creatures here are not just surviving, they are thriving. The entire system is built on that flora. Let's look closer at the foundation. The plant you see everywhere is a type of seed fern, likely from the genus Dicroidium. These are the grass and trees of their day, all in one. You reach out and touch a leaf. It feels less like a plant and more like a piece of tough, waxy plastic. This is a critical adaptation, just like the waxy skin on a modern cactus, all designed to do one thing: minimize water loss. Don't let a single precious molecule of H2O escape. These plants are architectural marvels of survival. This is a key mainstream fact of Triassic paleobotany. They had complex root systems to grab any moisture from those violent mega-monsoon floods, storing it for the long, brutal, dry season. But they also had seeds, which gave them a huge advantage over their simpler, spore-bearing fern cousins. A seed is a survival pod. It's a packed lunch for the plant embryo with a tough coat, allowing it to wait in the dry, baked soil for months or even years until the rains finally come. You climb a low, rusty red hill, and you can see that the landscape isn't uniform. Up here, in the slightly cooler highlands where a bit more moisture might be captured from passing clouds, you see different trees. These are the ancestors of our modern conifers. Early pines and araucaria, the monkey puzzle tree lineage, form sparse, tough forests. They have their own adaptations, needles instead of leaves, deep taproots to survive. So the world is a patchwork. Vast lowland plains of seed ferns and rugged highlands of primitive conifers. How do we know this so precisely? We have a time machine made of dust. The scientific evidence comes from palynology, the study of fossilized pollen. When scientists drill deep core samples into these ancient red rock formations, they hit the layers from before the catastrophe. And those layers are choked with pollen. They are dominated, almost to the exclusion of all else, by the pollen of seed ferns. This is our baseline. This is the fingerprint of the normal world. It tells us, with microscopic certainty, that this was a planet covered, coast to coast, in this specific, specialized, arid adapted flora. This brings us to the most important concept of this old world. It is built for specialists. Every creature you are about to meet, from the smallest to the largest, is perfectly adapted to this specific, arid, mega-monsoon climate. Their jaws are designed to eat these tough, waxy plants. Their bodies are designed to withstand the heat and the drought. Their life cycles are timed to the floods. It's a world of interlocking, custom-made parts. Paleobotanists still debate the true appearance of this world, arguing whether these dense stands of dicroidium formed true, tall forests, or were more like vast, impenetrable shrublands, and how they managed to thrive in such a high heat and likely high CO2 environment. But that specialization is a trap. This whole ecosystem is a beautiful, intricate, and successful machine. But it only has one on switch. It is optimized for one single climate, one single set of rules. It is strong. Yes, but it is brittle. Its perfection is, in fact, its greatest weakness. And it has no idea, no inkling, that the rules of climate, the very foundation of its existence, are about to be rewritten. The ground has not yet begun to tremble, but the trigger for the apocalypse is already being set. So you're standing in this brittle, specialized world, a world balanced on the edge of a pin. Let's zoom out and truly appreciate the stage on which this fragile drama is set. The problem isn't just the plants, it's the planet itself. You are so deep in the interior of Pangea that the very concept of coastal is a foreign one. The Panthalastic Ocean, that single planet-spanning sea, is thousands of kilometers away in every direction. This isn't just a big continent. Its sheer, uncompromising size is the engine of this entire climate. This geography creates the mega-monsoon. You have to understand, the seasons you know, spring, summer, autumn, winter, they do not exist here. They are a luxury for a planet with fragmented continents and balanced oceans. Pangea has only two modes, on and off. You experience the dry season first. It is an oppressive, endless thing that stretches for months. The sun is not a friendly yellow ball. It is a relentless, white-hot forge, baking a sky that has forgotten the color blue. The land beneath your feet shows the scars of this abuse. This is the red rock world you saw in the distance. Now you're walking on it. The soil, the cliffs, the vast canyons, they are all a spectrum of rust, from deep crimson to pale orange. This isn't just a pretty color. This is hard scientific evidence of the climate. It's a geological formation known as a red bed. The iron minerals in the dirt, with no regular moisture to protect them, are completely oxidizing in the dry air. They are, quite literally, rusting. You are walking on a landscape of pure continental-scale rust. You're dying of thirst. You've seen no water since we arrived. You look for a river, a life-saving blue line on the map. You find what used to be a river. It is a vast, sandy, braided chasm, hundreds of meters wide. But there is no water. It is a ghost. These are the ephemeral rivers of Pangea. This is a key mainstream geological fact of the Triassic. For most of the year, they are just dry, dusty highways, corridors of cracked mud and sand. Life doesn't cluster on the banks, because the banks are a lie. Life huddles in the dry riverbed, burrowing deep into the sand, praying for the memory of water. And then, the on switch is thrown. The mega monsoon arrives. It's not a gentle rain. It is a planetary-scale failure of the climate system. It's a quirky and terrifying tidbit of geophysics. Pangea's immense landmass heats up so much during the dry season that when the atmosphere finally shifts, the ocean-borne moisture doesn't arrive as a season. It arrives as a front, a wall of water. The ephemeral rivers you were standing in become, in a matter of hours, raging, sediment-choked torrents of unimaginable power. They are not life-giving rivers. They are agents of erosion, tearing the land apart. Then, just as quickly, it's over. The flood pulse moves on, and the long, baking, dry season returns. Now you understand. This is the world the seed ferns, with their waxy leaves and hardy seeds, were built for. This is the brutal bipolar cycle of drought and deluge. And scholars still argue about the exact nature of this cycle, debating whether it was one single planet-wide wave or a series of smaller, shifting regional deluges. But either way, this is the system. And it is this system that the old kings of this world have mastered. You look out across the vast, rust-red plains, scanning the horizon for the rulers of this ancient world, and you see them. But put away your storybook images. They are not dinosaurs. You haven't seen a single terrible lizard yet. Not one. The creatures that own this planet are something far stranger, and perhaps more familiar. You see a herd moving in the shimmering heat. They are Dicinodons. This is the dominant group of large land animals on Earth. And here is a quirky, mind-bending tidbit. These are not reptiles. They are synapsids. Like you. They are, in the complex tree of life, on the same great branch that would eventually lead to mammals. These hippo-sized giants are, in a very real sense, your impossibly distant cousins. A specific species, a herd of placarias, trundles past you. They are magnificent and utterly bizarre. They are the cattle of the Triassic, and they are built like tanks. Each one is the size of a large cow or a small hippo, a low-slung, barrel-chested body moving on 4 powerful, sprawling limbs. They have no front teeth, just a powerful, turtle-like beak for slicing, and most dramatically, 2 prominent tusks pointing down from their upper jaws. They move with a slow, ponderous confidence. They have no natural predators they can't handle. They are the system. This is not just a guess. The scientific evidence of their specialization is etched into their skulls. Paleontologists have studied their jaws for decades. That beak is a perfect guillotine, designed for one purpose, to shear through the tough, fibrous, waxy stems of the seed ferns. When the dry season gets truly bad, their powerful neck muscles and those tusks allow them to dig into the baked earth, pulling up the tough roots and tubers that other animals can't reach. They are custom-made, living machines, perfectly designed to harvest the dicroidium flora. They aren't alone. Grazing near them, you see another stranger group of herbivores, the rhynchosaurs. These are smaller, reptilian creatures, but they are also specialists. They have bizarre, shearing beak-like jaws and batteries of teeth fused to the bone, also designed to process very specific, tough-to-eat plants. This world, you realize, is not one of generalists. It is a world of fine-tuned specialists, an intricate web where every creature has its lock and every plant has its key. And the Dicinodons are the master locksmiths. It's a mainstream historical fact that these were, perhaps, the greatest success story in Earth's history. Until now. They were one of the very few groups to survive the Permian extinction, the Great Dying, that wiped out over 90% of all life on Earth. They walked through the gates of that apocalypse, found a new, emptier world, and absolutely dominated it. For millions of years, from the South Pole to the North, the most common large animal on Earth was a Dicinodon. And yet, there are still mysteries. Paleontologists still openly debate the true purpose of those prominent tusks. Were they for defense against the predators we're about to meet? Were they a social display, like a deer's antlers, to impress mates? Or were they primarily tools, used like shovels to dig for roots and water in the brutal dry season? The answer is likely all of the above, but it shows that even for an animal we know so much about, there are still basic questions we can't answer. But for now, you just watch the herd. The sheer biomass of them is staggering. Thousands of them, weighing tons apiece. They are the base of a massive food web. They are the great, thudding heartbeat of Pangea. And that entire massive, successful, globe-spanning dynasty is built on a single fragile foundation: the seed fern. They are perfectly adapted to eat it, and they can eat nothing else. Where there are vast, slow-moving herds, there are always hunters. That comfortable grazing confidence of the Dicinodons only exists because the predators allow it. You're watching the herd, but you get that prickling feeling on the back of your neck. You are also being watched. You scan the sparse cover of seed ferns and the rocky outcrops, and you see it. It's not moving, but its stillness is a threat. You see a Postosuchus. This is the apex predator of your world. It is the thing that even the hippo-sized Dicinodons have nightmares about. It looks like something from a fever dream. A creature with the armored, scaly skin and terrifying, tooth-filled jaws of a crocodile, but propped up on 4 powerful pillar-like legs that hold its body high off the ground. Some studies suggest it could even rear up and run on 2 legs for short bursts. It is a land crocodile on stilts, and it is the size of a grizzly bear, or larger. Now, your brain, conditioned by movies, screams dinosaur. You must fight this urge. This is not a dinosaur. It is a Rawisuchian. This is a crucial distinction. It belongs to the greater group of archosaurs, the ruling reptiles, just like dinosaurs and crocodiles do. But it's on a completely different branch of the family tree. Think of it this way. Rawisuchians are the lions of this ecosystem, and the dinosaurs, well, we'll get to them. These Rawisuchians, like Postosuchus, are the top carnivores across Pangea, and they are terrifyingly effective. The food web, you realize, is brutally simple and clear. It's a perfect, stable pyramid. At the base, you have the specialized flora, the seed ferns. On the next level, you have the specialized primary consumers, the Dicinodons and rhynchosaurs, perfectly built to eat those ferns. And at the absolute peak, you have the specialized apex predators, the Rauisuchians, perfectly built to hunt the Dicinodons. This stable, three-tiered system is the key ecological fact of the late Triassic. Everything is in its place. The seed ferns feed the Dicinodons. The Dicinodons feed the Rauisuchians. Rinse, repeat, for millions of years. What makes these Rauisuchians so effective is their unique evolutionary design. Here is a fascinating and quirky tidbit. Paleontologists have long been amazed by their hips. They didn't have the sprawling legs of a modern lizard, nor the fully erect legs of a dinosaur or mammal. They had a unique, pillar-erect hip, a different parallel solution to the problem of how to get a giant, heavy body to move efficiently on land. Scholars still debate just how agile this made them. Were they fast-running pursuit predators or lumbering ambush hunters? The fossils suggest they were, at the very least, efficient enough to catch a Dicinodon, which is all that mattered. So the stage is set, the main characters are here, the mighty Placerias and the terrifying Postosuchus. So where are the dinosaurs? You've been looking for them. You finally spot one. A tiny flicker of movement in the undergrowth. A small, bipedal creature, maybe the size of a chicken or a small turkey, darts from one shadow to the next. It's a Eoraptor, or something like it. This is the critical point. This is the reality check of the Triassic. Dinosaurs exist. They are here. But they are nothing. They are ecologically irrelevant. They are the rats and raccoons of their world. They are small, rare, and live in the absolute margins of this ecosystem, just trying not to get stepped on. They are generalists, eating insects, small lizards, maybe scavenging the scraps from a Rauisuchian's kill. They are, in no uncertain terms, nobodies. The world is owned by the old kings, the specialist Dicinodons and the specialist Rauisuchians. They are the masters of this arid, stable, seed fern-based world. They have perfected it, and their reign, which has lasted for tens of millions of years, is about to end, not in a great battle, but in a flood that will wash their entire specialized world away. You leave the arid, stable heartland of Pangea and you travel west. You walk for weeks, for months, across that rust-red desert, until you finally smell a change in the air. You smell salt. You've reached the coast of the great Panthalastic Ocean. You are standing on a beach that will, in 234 million years, be lifted, twisted, and pushed north to become parts of British Columbia and Alaska. You're looking out at the waves, and that is when you feel it. The ground shudders. It's not a sharp, cracking jolt like an earthquake. It's a deep, resonant groan, a vibration that you feel in your bones, as if the planet itself has indigestion. And it doesn't stop. It's a constant, low-frequency hum of immense power. You are standing on the edge of the apocalypse. This is the Wrangellia Large Igneous Province. Forget any image you have of a single, neat, cone-shaped volcano like Vesuvius or Fuji. This is not a volcano. This is a LIP, a large igneous province. And the scientific evidence for this event points to something far more terrifying. Fissure eruptions. This isn't a mountain exploding. This is the planet's crust splitting open. You look to the north, and the horizon is on fire. What you're seeing are not mountains. They are curtains of fire, fountains of lava being shot hundreds of meters into the air from great glowing cracks in the ground. These fissures are not small. They are hundreds of kilometers long. Magma, fresh from the Earth's mantle, isn't building a polite little cone. It is flooding out, like a bleeding wound. You watch as rivers of molten rock, far hotter and more fluid than any modern Hawaiian eruption, pour across the landscape. They move with terrifying speed, vaporizing everything in their path, and flow directly into the sea, which explodes in continent-sized clouds of steam. The sound is a constant, deafening roar that drowns out the ocean. And now you must try to comprehend the scale. This isn't an event that lasts for a day or a week. Here's the truly mind-bending part. You sit and watch, and the eruption doesn't stop. You could live your entire life on this beach and die of old age, and the fissures would still be erupting. Geologists have dated these rocks. This eruption, this province, continued on and off for hundreds of thousands of years. We can still see the evidence today. You can go to Western Canada and Alaska and walk on these rocks. It's a mainstream geological fact that the lava piled up in some places thousands of meters deep. It eventually covered an area of millions of square kilometers. It is one of the largest and most sustained volcanic events in the last 500 million years. You look at this wall of fire, this ocean of lava, and you think, this is it. This is the catastrophe. You would be wrong. The lava, as terrifying as it is just a local problem. It's killing everything here on this coast, but the rest of Pangea, thousands of kilometers away, is fine. The Dicinodons are still grazing, the Postosuchus is still hunting. The real catastrophe, the one that will kill them all, is invisible. It's not the lava. It's what's being pumped out of those fissures, rising high above the flames and smoke, and entering the global atmosphere. The air itself is about to become the weapon. The air itself has become the enemy. As you stand there, watching the curtains of fire, you notice the first change. The smell. It's not just the acrid smoke of burning forests. It's something sharper, something more chemical. It's the rotten egg stench of sulfur, and it burns your eyes and catches in the back of your throat. This is the first of the invisible weapons, the volatiles dissolved in the magma, now released. Sulfur dioxide, or SO2. This gas is a powerful short-term trickster. Here's a quirky scientific tidbit. The first thing these eruptions do, before they heat the world, is cool it. The SO2 molecules rise high into the atmosphere and combine with water vapor to create tiny droplets of sulfuric acid. These droplets form a bright, hazy veil that reflects sunlight back into space. You feel it on your skin. The air, despite the rivers of lava, feels suddenly unnaturally chilly. This is a volcanic winter, a brief, sharp, cold snap. And then, that sulfur acid-laced moisture comes back down. The first rains to fall from this new apocalypse are not water, they are acid. This acid rain begins to poison the landscape, scalding the leaves of the tough seed ferns and conifers and turning the freshwater streams and coastal oceans acidic. The Dicinodons, still grazing peacefully thousands of kilometers away, don't know it, but their world is already being poisoned from the sky. But this effect, the cold snap and the acid rain, is a short-term crisis. The SO2 and the acid droplets wash out of the atmosphere relatively quickly, perhaps in a few years or a decade. They are just the prelude. They are the opening act for the real killer, the one that will change the rules of the planet. That real killer is carbon dioxide. CO2. It's invisible. It's odorless. and for every ton of sulfur being pumped into the air, there are hundreds or thousands of tons of CO2 coming with it. Billions and billions of tons of it, dredged up from the Earth's mantle where it has been locked away and pumped directly into the sky. You are standing at the exhaust pipe of a planetary engine. Unlike the sulfur, the CO2 does not wash out. It stays. It lingers in the atmosphere, and it builds up. And here you are witnessing the on switch for a runaway greenhouse effect. This is, of course, a mainstream historical fact, the simple physics that will seal the world's fate. Carbon dioxide is a greenhouse gas. It's a heat-trapping blanket. It lets the sun's visible light pass through, warming the Earth's surface. But when that surface tries to radiate the heat back out into space as infrared radiation, the CO2 molecules in the air just catch it. They absorb that heat and re-radiate it in all directions, including right back down at the ground. Without any greenhouse effect, Earth would be a frozen ball. But the Wrangellia eruptions are overloading the system. You are force-feeding the atmosphere a high-carbon diet, and the planet is beginning to run a fever. How do we know this? 234 million years later. How can we be so sure? Because the volcanoes left a fingerprint, an unerasable chemical signature in the rocks. This is the core scientific evidence. The carbon being pumped out of these fissures, carbon from the Earth's mantle, is different. It's isotopically light. It has less of the heavy carbon-13 isotope and more of the lighter carbon-12. When geochemists analyze the rock layers from this exact moment in time all over the world, they find a sharp negative excursion in the carbon-13 ratio. That is the nerdy scientific way of saying, we found the volcano's fingerprint. We can see this massive injection of light volcanic carbon in the limestone of the Alps, in the fossilized wood of China, in the ancient soils of Arizona. It's a global signal. And there's more. We also find elevated levels of mercury in the exact same layers. Mercury is another quirky tidbit volatile that is released in massive amounts during these kinds of eruptions. The carbon-13 spike and the mercury spike, appearing at the same time, are the undeniable smoking guns. Geochemists and climate modelers still debate the exact amount of CO2 and the precise speed of the excursion. Was it one massive pulse or a series of smaller ones? Did CO2 levels double or quadruple? But the what is not in doubt. The that is settled. The world's thermostat is being hijacked. The air is now the enemy. The old, arid world of the Dicinodons is now living on borrowed time. The CO2 isn't stopping. You have to understand that. The sulfur washes out, but the carbon stays. It lingers. The Wrangellia fissures are still erupting, day after day, century after century, pumping more and more of this invisible, heat-trapping gas into the sky. The planet's natural sinks, the oceans and plants, are trying to absorb it, but they are overwhelmed. It's like trying to bail out a sinking ship with a teaspoon while a fire hose is blasting water in. The concentration of CO2 in the atmosphere is rising, and it's rising relentlessly. And now, the greenhouse effect truly takes over. The planet's fever, which was already high, begins to spike. Climate models based on this CO2 spike, a mainstream scientific fact, show the global mean temperature ticking upward. It's not a slow, gentle warming. It's a geologically violent shove. The global thermostat knob is cranked. 4 degrees Celsius. Then 5, then perhaps as much as 7 degrees hotter than the already warm baseline. You feel it on your skin, even thousands of kilometers from the eruptions. The heat is no longer the dry, baking heat of the old Pangean desert. This is something new. This is a suffocating, damp heat, a steam room heat. The air is thick and heavy, and it holds on to the warmth. Breathing feels like a chore. But the real action, the true engine of the coming catastrophe, isn't happening on land. You must turn your gaze to the ocean, that single, planet-spanning sea. The Panthalassa. You are standing on its new, acid-scorched shore. The water is unnaturally warm to the touch. And here is the simple, brutal physics that will doom this world. Warmer water evaporates faster than cool water. It's not a complicated idea. You see it every day when you boil a kettle. You are now standing on the shore of a planet-sized kettle that is being brought to a rolling boil. The superheated surface of this entire ocean begins to change. It's no longer just evaporating. It is pumping water vapor into the atmosphere at a rate that is hard to comprehend. Trillions and trillions of tons of H2O rising as an invisible, gaseous flood. The sky is drinking the sea. And here is the tipping point. Here is the moment the climate system breaks and the feedback loop begins. Because here is a quirky and terrifying tidbit of atmospheric science. Water vapor is also a greenhouse gas. In fact, it's one of the most powerful ones. You see the loop, don't you? It's a vicious, self-perpetuating cycle. 1. The volcanic sea. O2 heats the air. 2. The hotter air heats the ocean. 3. The hot ocean evaporates, pumping massive amounts of water vapor into the air. 4. That water vapor itself traps more heat, making the air even hotter. 5. The even hotter air heats the ocean even more. 6. The even hotter ocean evaporates even faster. More heat, more evaporation, more water vapor, more heat. This is the runaway feedback loop. It is a planetary chain reaction. The climate is no longer just warming. It is accelerating towards a new catastrophic state. The old rules are gone. The hydrological cycle, the calm, predictable movement of water from ocean to air to land and back, is not just changing. It has been hijacked. It has been put on methamphetamines. It is going into overdrive. The atmosphere, the entire global sky, becomes saturated with moisture. It is holding as much water as it can possibly hold, and then some. It is a sponge that has been so utterly soaked that a single touch would send water gushing out. You look up. The sky is no longer a stable, blue, or even cloudy thing. It is a bruised, heavy, ominous grey. It is a single, planet-wide, supersaturated cloud bank. Historians of the deep past and climatologists still debate the exact forcing mechanisms. How much of the warming was CO2 versus water vapor, and how fast the loop spun up. But the result is undeniable. The sky is no longer a passive ceiling. It is a loaded weapon. The air itself has become a reservoir, holding an ocean's worth of water, just waiting for the trigger to pull. And all of that water, all of that evaporated sea, it has to come back down. You are back in the heart of Pangea, thousands of kilometers from the Wrangellia eruptions. But you are no longer safe. The sky above you is no longer your friend. It's a dark, heavy, oppressive ceiling, saturated with the water from a boiling ocean. The air is so humid, you feel like you're breathing in a sauna. The old rhythm of the world begins to break. That brutal, predictable, mega monsoon cycle. It starts to stutter. You're waiting for the long, blazing, dry season to begin, but it's late. The wet season, which should have been a violent, weeks-long flood, just lingers. It rains, it stops for a day, and then it rains again. The ephemeral rivers, which should have dried up, are still running, sluggish and muddy. The next year, the dry season is even shorter. Maybe just a few months. The wet season is longer, heavier. The Dicinodons, the great herds, are confused. Their entire biology, their breeding cycles, their migrations, are all timed to that old, reliable clock. And that clock is now broken. And then, 1 year after a wet season that seems to stretch for an eternity, the dry season just doesn't come. It starts to rain, and it doesn't stop. You have to understand what this means. When we say it rained for 2 million years, it's not a Hollywood movie. It's not a single, continuous, globe-spanning thunderstorm without pause. That's a physical impossibility. The Carnian Pluvial episode wasn't a storm, it was a climate state. This is the crucial, mainstream scientific fact. The planet's entire default setting was changed. The atmosphere was so overloaded with CO2 and water vapor, the feedback loop so supercharged, that the normal state of the sky was about to rain. Precipitation was no longer a special event. It was the baseline. It was the planet's new, miserable normal. You are now living in a pluvial world. That is the scientific term. And it means that the old binary system of wet and dry is gone. That system is extinct. You now live in a world that has only 2 seasons, wet and wetter. It's a world of permanent lead-grey skies. It's a world where the air is always 100% humidity, a suffocating, clammy blanket that sticks to your skin. It's a world where nothing ever gets dry. The ground, which was once baked red, hard, cracked earth, is now just mud. It's a liquid landscape. But what did this rain actually feel like? Here, paleoclimatologists still openly argue about the texture of the precipitation. This is a fascinating debate. Was it a constant, miserable, 2 million year-long Scottish drizzle? A relentless fine mist that just soaked everything, everywhere, all the time? This would have been its own kind of sensory hell, a world of grey, muffled sounds where the sky just wept endlessly. Or was it something far more violent? This is the other side of the debate, and the one that the rocks seem to support. The scientific evidence we find in the geological record isn't of gentle, soaking rains, it's the signature of violence. We see massive, chaotic layers of rock, scoured out river channels, and deltas of sediment dumped into the ocean. This suggests the wetter season was a period of non-stop, hyper-violent, tropical thunderstorms. Imagine it. A sky that is in a constant state of electrical discharge. The air crackles with ozone. The thunder is not an event. It is a constant rolling drumbeat that blends into a single, deafening roar. The lightning flashes are so incessant that they are the new daylight. And the rain doesn't fall in drops, it falls in sheets, in water bombs that explode on the ground. This seems more likely. A hypercharged hydrological cycle wouldn't be gentle. It would be an unstable, explosive, chaotic mess. So you are living in a world of near-constant, terrifyingly violent thunderstorms, punctuated by periods of less violent thunderstorms. The year is 234 million BCE. You have just taken your first step into the Carnian Pluvial episode. You look up into that grey, flashing sky, feeling the first of trillions of drops on your face. And you have to understand, this rain, this sound, this smell of ozone and mud, it will not stop. Not in your lifetime, not in your children's lifetime, not in 1,000 generations. The old kings, the Dicinodons, the Rauisuchians, they are all about to be washed away. You are standing in the opening act of a flood that will not end until long after you and your entire world are just a memory, pressed into a line of black rock. The first thing that breaks you, long before the hunger or the mud, is the sound. Your brain is not built for this. It is hardwired to find patterns, to seek signals in the noise. It is designed to use quiet as a baseline, a canvas against which the important, life-saving sounds, a predator's footfall, a potential mate's call, the gurgle of fresh water, can be heard. That canvas is gone. It has been shredded. The first sound you notice is the impact. It's not the gentle, romantic pitter-patter of a spring shower, the sound that writers use to evoke coziness. This is a percussive assault. The atmosphere is so saturated that the drops are not drops. They are heavy, weighted pellets of water, and they are falling from a great height. The world is being drummed, a relentless, chaotic, high-speed tattoo on every single surface. It's a sound like billions of tiny hammers, all striking at once, without a beat or a rhythm, just a wall of high-frequency noise. Then, beneath that, you hear the water, not the falling, but the moving. You realize you are surrounded by waterfalls. Every cliff face, every gentle slope, every rocky outcrop has become a cascade. It's a sound you're not used to, a constant regional roar of white noise, the sound of 1,000 rivers that shouldn't exist, all flowing at once. And then, above it all, you hear the sky itself. The thunder. With this much atmospheric instability, this much heat and moisture smashing together, the sky is in a constant state of electrical discharge. This is a key mainstream fact of intense hydrological cycles. You are living inside a planetary-scale thunderstorm that never moves on. The thunder isn't a boom that makes you jump, followed by silence. It is a constant, rolling groan that blends into the background roar. The air crackles with it. You can smell the ozone, a sharp, metallic tang that is the scent of the sky tearing itself apart, over and over. But the most terrifying sound is the one that comes from below you. It's the sound of the earth itself beginning to move. You hear the deep, sickening thump of mudslides in the distance, a sound like a giant exhaling, as entire hillsides, waterlogged and heavy, give up and slide into the valleys. And you hear the rivers. Those ephemeral rivers, the dry, sandy ghosts, they are now monsters. And the scientific evidence for this is undeniable. When we dig into the rock from the Carnian period, we don't just find the black shales of quiet swamps. We find massive, chaotic layers called conglomerates. These are simply fossilized torrents. They are rocks made of huge, jumbled, rounded pebbles and boulders, all smashed together. This isn't the work of a gentle stream. This is the signature of a raging, violent, high-energy flood. And you are hearing it. You hear the hiss of a freight train that never passes, a sound so loud it vibrates in your chest. It's the sound of those new rivers, choked with silt and sand and pebbles scouring the bedrock. You are hearing the sound of canyons being born. Here's the quirky fringe science tidbit. This is the birth of soundscape paleoecology. In the old world, a Postosuchus could have heard a Dicinodon walking a kilometer away. A small mammalomorph could have heard an insect skittering on a rock. Now? That is impossible. The world has become a deafening, confusing mess. For organisms that relied on sound to hunt, to hide, or to find mates, their primary sense has just been rendered useless. Paleoclimatologists still debate the exact acoustic texture of this world. Was it the constant, deafening, high-frequency hiss of a global drizzle, a sound that would shred your sanity? Or was it, as the rocks seem to suggest, a lower-frequency, percussive roar, a world of constant thunderstorms, explosions, and grinding, moving rock? You try to sleep. You cover your ears. It doesn't matter. The sound is not just in the air. It is the air. It is the ground. It is the world. There is no quiet. There is no silence. There is no peace. The world is a drum, and the rain is a relentless 2 million-year-long solo that is just getting started. The sound is a constant physical pressure. But after a few months, a few years, your brain does the only thing it can. It buries it. It turns the eternal screaming roar into a new, terrible silence. But you can't bury the second thing. You can't ignore what's in the air, what you are breathing in. The smell. At first you almost recognize it. It's petrichor, that lovely earthy electric clean smell of rain hitting dry ground. But the ground here hasn't been dry in 1,000 years. This isn't the fresh, clean scent of a summer shower. This is petrichor that has been left to fester. It's a cloying, heavy, permanent smell. It's the smell of wet clay, wet dust, and that sharp, metallic tang of ozone from the endless lightning. It sticks to the back of your throat, and you can taste it on every breath. The air is no longer air. It's a thick, smelly aerosol. And then a new smell joins it. It starts subtly, a faint, musty note under the wet clay. But it grows, day by day, year by year, until it overpowers everything else. It is the smell of rot. You are smelling the death of an entire world's flora. You are smelling the past decomposing. Remember the seed ferns? The tough, waxy-leaved, specialized plants that built this entire ecosystem? The ones that fed the Dicinodons? The ones that had mastered the dry, brutal, mega-monsoon world? Their mastery has just become their death warrant. They were built for drought. They were not built for this. You walk through what used to be a sparse, dry forest of them. But it's not a forest anymore. It's a swamp of skeletons. The mud, which is now permanent and ankle-deep everywhere, has suffocated them. Their complex, arid-adapted root systems have drowned. They can't breathe. They are rotting from the ground up, en masse. You are not smelling one rotting plant. You are smelling billions of them, a continent-wide simultaneous decay. The air is thick with the sickly sweet, pungent stench of a world's worth of vegetation turning to black, slimy mush. And in this world, a world that is dark, permanently damp, and now full of a limitless buffet of rotting matter, a new kingdom rises. Not an animal, not a plant. A new kingdom takes over the planet.
Fungi!
Before they were a humble hidden part of the system. Now they are the masters. This is their moment. You are witnessing a global fungal explosion. You see it everywhere. It's the velvety blue-green mildew covering the rotting trunks of the seed ferns. It's the vast, leathery conch fungi growing like shelves on the dying conifers. It's the thread-like mycelium, a white, stringy network that now covers the mud, stitching the whole rotting world together. The air is now thick with a new smell, layering on top of the petrichor and the plant rot. It's the musty, damp, basement smell of mildew. It's the rich, earthy, and slightly nauseating smell of active decay. You are breathing in spores. Trillions of them. This isn't speculation. This is the hard scientific evidence. When geologists and paleontologists look at the rock layers from this exact moment in time, they find something astonishing. They call it the fungal spike. It's a global phenomenon. In the layers before the rain, the rock is full of seed fern pollen. In the layers after the rain begins, that pollen vanishes. It's gone. And it is replaced by a single overwhelming signal, a massive spike in the number of fossilized fungal spores. This is a mainstream scientific fact, a fingerprint that shows us, at a microscopic level, the exact moment the old world died, and the great global compost pile was born. Here's a quirky, mind-bending tidbit. For a brief period, the largest organism on Earth might have been a single sprawling mycelial network, fueled by the death of Pangea's flora, a single interconnected mat of fungus that could have covered thousands of square kilometers. Paleomycologists, the scientists who study ancient fungi, still debate the nature of this spike. Was it a diverse explosion of thousands of different kinds of rot and mildew, all feasting at once? Or was it something more sinister, the rise of one or two disaster species of fungus, an opportunistic planetary-scale mold that simply took over everything? You don't care about the details. You just know that the world stinks. It is the smell of an ecosystem's compost phase. The old world, the world of the Dicinodons and the seed ferns, is not just being drowned. It is being digested. It is being broken down, liquefied, and turned into a slurry, a rich, fungal processed fuel ready for whatever comes next. The sound is a prison. The smell is a miasma. But the feel is a betrayal. Your own skin, your largest sensory organ, is now a source of constant, miserable data. You can't get dry. Ever. It's not just that you're being rained on. That you could almost understand. You could huddle under a rock ledge or in a cave, just for a moment's relief. But you can't, because you are breathing the water. The humidity is 100% all the time. There is no air. There is just a thick, heavy, water-saturated gas that your lungs are struggling to process. You wipe the water from your face, and a second later, it's back. Not from the rain, but from the air itself, which has condensed on your skin, on your hair, on every surface. You are in a permanent state of clammy. Your skin is waterlogged, pruned, and raw. Small cuts don't heal. They instantly fester, attacked by the fungal spores and bacteria that are thriving in this global swamp. You feel a constant, maddening itch. But the physical discomfort is nothing compared to the visual, psychological shock. You look out, and your entire world has been stolen from you. Remember the old world? The world of the old kings? It was a world of color. It was the blazing rust red of the iron-rich soil. It was the sharp, burnt orange of the canyons. It was the clear, deep, unforgiving blue of the dry season sky. It was a world of harsh, bright, terrible beauty. That world is gone. It has been erased. You are now living in a monochromatic nightmare. The world has been reduced to two colors, gray and green. The gray is everything. It is the sky, a permanent, featureless, leaden ceiling that hangs just above your head. There is no sun. There is no moon. There are no stars. There is only day gray and night gray. The light is a flat, dim, depressing diffusion, as if you are living at the bottom of a murky fish tank. The gray is the rain, a constant shimmering curtain of mist that reduces your visibility to a few dozen meters. The world beyond your immediate, miserable bubble is just gone, lost in the gloom. And then there is the green. This is the new color, the color of the invasion. As the seed ferns rot and turn to black slime, the opportunists are surging. You see ferns, real ferns, not the tough seed-bearing ones, unfurling in every shadow. Their spores, light as dust, have ridden the new, wet winds, and they are colonizing the entire continent. And you see the conifers. This is a key paleobotanical fact. The ancestors of our pines and redwoods, with their deep, tenacious root systems, are thriving in the waterlogged soil that killed the old guard. A new, dark, damp forest is being born, a forest of green so dark it's almost black. This isn't the life-giving green of a spring meadow. This is a cold, alien, reptilian green. But the grey sky and the green rot are not the worst part. The worst part is under your feet. The ground itself, the one solid thing in the universe, is gone. It is not soil anymore. It is mud. Try to comprehend this. It's not a mud patch by a river. It is a planet of mud. The dry, cracked, baked red earth has been so saturated, so pulverized by 2 million years of rain, that it has lost all its structural integrity. It has become a single, continent-spanning bog. You take a step. Your foot sinks to the ankle, to the calf. The mud makes a sickening, sucking sound as you pull it free. It's a thick, non-Newtonian slurry of decomposed plant slime, fungal filaments, and liquefied clay. It's a quirky, muddy tidbit that this is the perfect medium for a special type of fossil. Trace fossils. We lose the skeletons of many animals as they just rot and sink, but we find their footprints, their struggle, their desperate last movements preserved in this global slurry. The world is now unstable. You are walking on a liquid landscape. And this is when you realize the true terror. This is the mainstream historical fact of the CPE. This is when the great erosion begins. The water isn't just falling anymore. It is moving. The rain is a scouring agent. It is sanding the continent down. You are watching the land itself dissolve. The solid ground of Pangea is being liquefied, picked up, and carried away in vast, muddy torrents, heading for the sea. Paleogeologists still debate the exact speed of this erosion, arguing over how many meters of solid rock were stripped from the continents during this episode. But the evidence is clear. The entire surface of Pangea was being remade, scoured down to the bone by water. The dry, cracked earth of the old kings is gone. The solid ground has been turned into a liquid weapon. The very solidity of the world has become a fading memory. You are watching the old world dissolve. The mud beneath your feet, the liquefied continent, is on the move. But remember that mystery of the black scar from the very beginning? That impossible layer of black, oily rock buried in the middle of a desert? You are standing at its birthplace. You are watching that scar form in real time. You're in what used to be a vast, dry desert basin, a low point in the arid red rock landscape. For millions of years, it was just a dusty bowl. Now, in the endless 2 million-year-long reign, it has become something new. It is a lake, a vast, shallow, stagnant, continent-sized lake. And it is a lake of death. It's not a clear, blue, life-giving body of water. It is a thick, black, soupy mess. All of the rot you've been smelling, the billions of tons of decomposing seed ferns, the mats of fungal slime, the dissolved organic matter from the dissolving soil, is being washed relentlessly into this basin. The lake becomes a toxic soup. The sheer amount of decay is so overwhelming that the bacteria feeding on it consume all the oxygen in the water. This is the critical step. This is the key scientific evidence. The basin becomes anoxic. It is a layer of water with no oxygen. This lack of oxygen does something crucial. It stops the decay. It acts as a perfect preservative. The organic matter, the dead plants, the fungal slime, the bodies of animals that fall in, they no longer rot down to nothing. Instead, they just settle. They sink in their preserved state to the bottom, forming a thick, black, oily ooze. You are watching the birth of a fossil fuel. Layer by layer, year after year, millennium after millennium, this black, organic-rich gunk accumulates. A millimeter of slime, a layer of mud. A millimeter of slime, a layer of mud. This goes on for 2 million years. This is the black shale. This is the coal bed. This dark, stinking, anoxic sludge at the bottom of a dead swamp lake is the very same rock that a geologist, 234 million years later, will hold in their hand, marveling at its impossible location in the middle of a desert. It is a tombstone. It is the compressed, cooked, and fossilized remains of the entire old world's flora. And in that sludge, we find other clues. Here is a quirky and fascinating tidbit. Some of these black shale layers are full of amber, little fossilized drops of tree resin. The new conifer forests, which are surviving this wet hell, are not happy. They are being stressed constantly by the damp, the fungal attacks, and the swarms of insects that are thriving in this new, rotting world. In response, the trees are bleeding resin, a sticky antiseptic sap to try and protect their wounds. That resin drips down, gets washed into the black lake, and is perfectly preserved in the anoxic ooze, trapping tiny insects and spores from this lost, wet world. The old red rock world, the world of iron oxide rust, is being buried. It is being covered by a thick, black, suffocating blanket of its own decomposed self. This is the geological scar itself. It's the single most dramatic piece of evidence, a literal line in the rock that separates the world before from the world after. Geologists and sedimentologists still argue over the exact extent of these basins. Were they a few continent-sized megalakes? Or were they a vast, interconnected network of thousands of smaller, swampy, anoxic ponds like a modern-day peat bog, but on a planetary scale? The answer is probably both. But it doesn't matter. The result is the same. The planet is laying down a global 2 million-year thick layer of black rock, a gravestone made of the dead for the world that was. The black, anoxic lakes you're watching are just one part of the new world. They are the destination for all that rot. But the rain isn't just a passive delivery system. It's not just falling. It has become an engine. It is an active, violent geological force. The rain is now working. It is a 2 million-year-long project of deconstruction. You are witnessing the birth of a new, hyper-erosion world. You are standing on a hillside, overlooking one of those old, familiar, ephemeral riverbeds. That dry, sandy, braided channel, the ghost river that only ran for a few weeks a year. It's gone. You can't even see it anymore. In its place is a monster. It's a river, yes, but not a river you would recognize. It is a churning, brown, liquid earth torrent, a kilometer wide, and it is raging. The sound you heard before, that freight train hiss? This is its source. The water is so thick with sediment, with the mud, sand, pebbles, and liquefied plants you've seen, that it's more like a slurry. It is abrasive. This is not just water flowing over a landscape. This is a landscape being scoured, sanded, and liquidated. You watch as the old, gentle banks of the river are undercut. A section of the hillside the size of a building, a chunk of the old, red, stable Pangea, just calves. It slides, with a sickening groan, into the torrent and vanishes, dissolved in seconds. The river is not following the old path. It is erasing it. It is carving a new one. These are not rivers. They are cannons, firing liquid sediment at the world. They swell into permanent, raging, unstoppable torrents. And they are everywhere. The entire supercontinent, once defined by its dryness, is now defined by these new, violent arteries. And they are not just digging down. They are digging new paths. Here's a quirky and terrifying geological tidbit. This is a world of constant, violent avulsion. Avulsion is the natural process of a river suddenly changing its course, abandoning its old channel for a new, steeper path. In our world, it's a rare, catastrophic flood event. In this world, it's Tuesday. You could be standing on what seems like solid ground, and a new, raging river could decide to cut through where you're standing in a matter of hours. The ground is not just mud, it's unpredictable. The entire hydrological architecture of Pangea, the fundamental plumbing of the continent, is being rewritten violently from scratch. This is not just a guess. The scientific evidence is brutal and unambiguous. When geologists find the rock layers from this period, they don't just find the fine black shales of the quiet lakes. They find massive, chaotic layers of conglomerate. These are rocks made of huge, rounded pebbles and boulders, all smashed and cemented together. This is the fossilized bed of one of these monster rivers. The size of the boulders tells us the speed of the water. This was not a river. It was a permanent, non-stop flash flood. We can also see scour marks, where these sediment-choked rivers literally carved grooves into the solid bedrock below, like a giant with a piece of sandpaper. And here's the mainstream historical fact, the one that is truly mind-bending. Many of the great river systems of our modern world, the great drainage basins that would one day define the breakup of the continents, the Amazon, the Congo, the Mississippi. They may have had their very first cuts during this pluvial episode. This endless rain wasn't just destroying a world, it was etching the blueprint for the new one. But paleogeographers still debate this. Was this erosion a uniform event, a simple sanding down of the entire continent at once? Or was it a more complex, localized process, where these new violent drainage basins formed in specific areas, leaving other parts of Pangea as vast, high-altitude, muddy plateaus? The rocks seem to suggest the latter, a world of contrast, of deep, violent new river valleys and high, waterlogged, swampy plains. So, the land is being dissected. What was once a vast, open, easily traversed plain, the perfect world for the great herds of Dicinodons to migrate across, is now becoming a maze. It is a network of deep, impassable, and incredibly dangerous river valleys. And this, you realize, is a new kind of filter. The landscape itself is now the predator. The world is being carved into thousands of isolated islands. This creates new, impassable barriers for animals. If your herd of Dicinodons gets trapped on one plateau, cut off by two new, raging, kilometer-wide rivers, you can't migrate. You are stuck. You will eat all the seed ferns on your island, and then you will starve. The geography is now an agent of extinction. The landscape is a filter, deciding who can move and who is trapped, who will be isolated, and who will be washed away. You've been so focused on the land, on the drowning plains and the fungal rot, that you've forgotten about the rest of the planet. You turn your gaze away from the muddy, dissected continent and look to the great oceans. You look to the endless Panthalassa and to the vast wedge-shaped Tethys Sea that cuts into Pangea. You might think, well, at least the oceans are fine. They're already water. What's a little more rain?
You would be dangerously, catastrophically wrong. The oceans are not fine. The oceans are dying.
Those monster rivers you were just watching, those kilometer-wide torrents of liquid mud that are scouring the continent, they are not just disappearing. They are going somewhere. All of that mud, all of that sand, all of that silt, all of the liquefied dead continent is being dumped relentlessly into the shallow coastal seas. You are witnessing a marine catastrophe on a scale that is almost impossible to imagine. You're standing at the new, muddy coastline. The water, which 10,000 years ago was a warm, clear, tropical blue, is gone. In its place is a vast, brown, murky soup. It's a permanent, planet-wide dead zone, a muddy halo spreading hundreds of kilometers out from the coasts of Pangea. The scientific evidence for this is one of the cleanest, most brutal before and after pictures in the entire geological record. It has a name, the siliciclastic switch. Let's break that down. Siliciclastic is just the nerdy word for rock made of silica or clay. Basically mud, sand, and silt. The stuff that erodes from land. The other kind of rock is carbonate. This is limestone. It's not from land. It is built by life. It's the skeletal remains of algae, plankton, and most importantly, reefs. And here is the mainstream historical fact. Before the rains came, the warm, clear, shallow seas of the Tethys and Panthalassa were home to vast carbonate platforms. These were the Triassic equivalent of the Great Barrier Reef, only bigger. They were sprawling, complex, beautiful ecosystems, cities built from the skeletons of coral-like sponges, algae, and microbes teeming with life. And in the rock record, we see these beautiful, clean, thick layers of limestone. Then the rain starts. And in the rock, the limestone stops. It doesn't fade out. It stops as if a line was drawn. And right on top of that clean, white limestone, there is a new layer. A thick, dark, ugly layer of black mudstone and shale. That is the siliciclastic switch. It is the exact moment the mud cannons from the land were turned on, and they buried the reefs. You are watching it happen. The reefs, the cities, are being choked to death. The filter-feeding sponges and microbes can't breathe in this muddy soup. The algae that need sunlight are plunged into a permanent brown darkness. The mud, tons and tons of it, is settling out of the water, burying the entire ecosystem alive under a blanket of sterile silt. This isn't just bad for the corals. This is a total ecosystem collapse. This is the mainstream paleontological fact of the CPE. Those reefs were the foundation. They were the habitat, the food, the nursery for everything. Now the water is a graveyard. The ammonoids, those beautiful spiral-shelled squid-like creatures, are experiencing a massive die-off. Their lineages are vanishing, their delicate filtering gills clogged with mud. The crinoids, those feathery plant-like sea lilies that filter-fed from the seafloor, their habitat is just gone. It is buried under 10 meters of anoxic sludge. The bivalves, the clams and oysters, which rely on stable, clean sediment, are being suffocated and poisoned. Here's a quirky, mind-bending tidbit. The volume of this sediment is so massive that it's not just polluting the ocean, it's actively filling it in. The coastlines of Pangea are being physically extended as the deltas of these new monstrous rivers dump millions of square kilometers of the old, dead continent into the sea. Marine paleontologists and sedimentologists still have a lively debate about the speed of this death. Was it a slow death, a few centimeters of mud a year for 1,000 years? A gradual, miserable suffocation that the reefs just couldn't fight? Or was it, as the sharpness of that switch in the rock might suggest, a far more violent, catastrophic event? Were there mud tsunamis, vast undersea landslides of this new, unstable sediment that just buried entire reef systems, Pompeii style, in a single day? The evidence seems to point to both. A slow, steady choking, punctuated by moments of catastrophic burial. The land is dying. And now the seas are dying too. The planet is being systematically sterilized, one ecosystem at a time. You pull your gaze back from the dead, brown, muddy oceans and return to the land. If you can even call it that anymore. The marine catastrophe is a symptom. The continental erosion is a symptom. You are now standing at the source of the sickness, the absolute root of the disaster. You are standing in the heart of the dying forests. You are back among the seed ferns, the dicroidium forests. Remember them? The tough, waxy, specialized plants that had mastered this world. The plants that formed the absolute, unshakable foundation of the entire Pangean food web. The bread that fed the Dicinodon cattle. They are dying. You are walking through a forest of them, but it is a forest of skeletons. The rain, which has been falling for 10,000 years, has done what the heat and the drought never could. It has broken them. Their specialization was their doom. This is the core paleobotanical fact of the CPE. Their complex, arid, adapted root systems were designed to seek and hoard scarce water from a seasonal flood. They were not designed to breathe while submerged, 24/7, in a permanent, anoxic, fungal-infested bog. They are, quite literally, drowning. You look at the base of a once mighty seed fern. Its trunk is a black, slimy, mildew-covered mess. The ground around it is not mud. It is a slurry, a black, bubbling mush of its own decomposed self. They are rotting from the ground up. The air, as you know, is thick with the sweet, nauseating stench of their decay. You walk for 100 kilometers, and it is the same. A planet-wide graveyard of skeletal, rotting seed ferns, their dead, waxy leaves plastered to the mud. How do we know this? How do we know it was them? Because they left a perfect record of their own death. The scientific evidence is, perhaps, the most dramatic in all of paleontology: the pollen record. When we drill core samples, the rock layers before the rain are a solid, dusty mass of seed fern pollen. It's almost all seed fern pollen. They owned the world. Then you reach the line in the rock that marks the start of the rain, and in the very next millimeter of rock, the pollen is gone. It's not a decline. It's not a fade. It's an erasure. Here is the truly quirky and terrifying tidbit. It is a cliff-edge collapse. The pollen just stops. It's as if a switch was thrown, and every seed fern on Earth, all at once, just gave up. And this, of course, is the great open scholarly debate. How fast was this geological instant? The pollen record is so abrupt, so shocking, that some scientists argue for a total botanical collapse in just a few thousand years, maybe even a few hundred years. Others argue it was a slower decline over tens of thousands of years. But in geological time, the difference is academic. It was a cliff. The world's primary producers were, geologically speaking, assassinated overnight. You must understand the scale of what you are witnessing. This is not a forest fire. This is not a regional drought. This is the equivalent of all grass, all shrubs, and all broadleaf trees on our modern Earth vanishing, everywhere, all at once. This is the extinction of the menu. The plants that had dominated Pangea for tens of millions of years, the bedrock of the entire complex, stable world of the old kings, are now a layer of black, rotting slime. The foundation of the global food web has just been pulled. But life abhors a vacuum. The old world is rotting, yes, turning into a black, fungal soup. But in that very same soup, the seeds of the new world are already taking root. As the seed ferns, the old guard, are suffocated and erased, the opportunists, the plants that had been living in the margins, begin their takeover. The planet-sized help wanted sign for a new flora is being answered. The first responders are the ferns, not the tough, seed-bearing ones, but the real ferns, the ones you'd recognize. You see them uncurling in the deep, wet shade, their iconic fiddleheads pushing up through the black mud. This is a key paleobotanical fact. Ferns are spore-based. A single fern can release billions of spores, each one a microscopic speck, lighter than dust. In this new, wet, windy world, that is a superpower. Their spores can travel for thousands of kilometers, crossing the new, raging rivers and muddy oceans that are barriers to everyone else. And they love this ground. They are thriving in the disturbed, waterlogged, rotting soil that killed the old masters. They are the ultimate disaster species, the first green life to recolonize the endless grey, muddy graveyard. But the ferns are just the ground cover. They are not the new architects of this world. The real winners, the new kings of the plant world, are the ones you see pushing up through the ferns. You see the conifers. It's a mainstream historical fact of paleobotany that the conifers were the great victors of the Carnian Pluvial episode. The ancestors of our modern redwoods, our pines, and our Araucaria, the monkey puzzle tree, or Chilean pine, were already here, living in the cooler, tougher highlands. And they had an adaptation, a lucky break in their design, that suddenly made them masters of this new, wet world. They had better roots. Their deep, tenacious, specialized root systems were simply better at surviving in waterlogged, anoxic soil. It's a quirky but crucial tidbit. Their roots could breathe, or at least tolerate the lack of oxygen, in a way the seed ferns just couldn't. So, as the seed ferns drown, the conifers explode. They spread from their mountain refuges and march down into the vast, newly fertilized lowland basins. They are the only things that can grow tall, and they do it with a vengeance. You are watching the world transform. The old world was a low, shrubby, open plain, a world of vast horizons, red soil, and bright, hot sun. That world is gone. In its place, a new world is being born. A world of dark, dense, tall forests. The conifers are shooting up, blocking out the dim grey light, creating a deep, permanent canopy. This is a profound, planet-altering change. For the first time, Pangea is a world of shade. The world is now cooler, at least at ground level, under this new, thick, insulating blanket of green. It's darker. It's wetter as the canopy traps the moisture, creating a permanent, misty, dripping greenhouse effect below. The very physics of the ground level has changed, and most importantly, the food on offer is now completely, totally different. The old, soft, nutritious, easy-to-digest seed fern buffet is closed. The restaurant is shut down. The new menu? It's awful. It's tough, resin-filled, waxy pine needles. It's hard, woody cones. It's thick, indigestible bark. This is not food for the old kings. This is food that fights back. A new flora has taken the throne. A new, dark, vertical, and indigestible world has been created. And this new world, you realize, has no place for the old rulers. It is waiting for new ones. You are now a witness to the consequences. The new, dark conifer forest is born. The old flora is dead. The foundation is gone. Now you watch the pyramid fall. You find one of them, a Platerias, one of the last of its kind. It's a lone bull, separated from a herd that maybe doesn't exist anymore. And he is confused. You can see it in his movements. His entire world, the one he was born into, the one his ancestors had mastered for 50 million years, is gone. He is trundling through the new, dark, fern-choked forest, and he is struggling. His heavy, low-slung, barrel-shaped body, so perfect for walking on firm, dry, red earth, is a liability here. With every step, his short, powerful legs sink deep into the anoxic, fungal-laced mud. You hear the sickening schloop as he pulls one foot free, only to have the other one sink. This land was firm before. This land was reliable. Now, just walking is a Herculean, exhausting effort. But the exhaustion isn't what's killing him. The hunger is. He is starving. He is surrounded by green. The world is, in fact, greener than it has ever been, but to him, it is a desert. It is a world of anti-food. He is driven by the ancient instinct. He must eat. He finds a plant. He sniffs it. It's a conifer sapling, one of the new invaders. He doesn't recognize the smell, but it's green. He clamps his specialized turtle-like beak down on it. That beak, a marvel of evolution, an instrument perfectly evolved to slice the soft, fibrous stems of a seed fern. He pulls. The sapling is tough, woody, and resinous. His beak, for the first time in its evolutionary history, fails to make a clean cut. He gets a mouthful of sharp, waxy needles and bark. He chews, but this isn't food. It's like you trying to eat a wooden board. The resin, a sticky, pine-scented glue, coats his mouth. He spits it out, confused and distressed. There is no nutrition here. This food is fighting back. He moves on, his massive body trembling. The hunger is a physical, gnawing pain. He finds another patch of green. The new ferns, the ones that have carpeted the world. They are soft. This must be it. He uses his beak and tusks to scoop up a huge mouthful of the wet, slimy fronds. He tries to chew, but he can't. This is a key, tragic, scientific fact. His entire digestive system, his gut, his flora is specialized, just like his beak. It is built to break down the specific chemical compounds of the dicroidium seed fern. These new ferns, they are poison, or, at the very least, they are so low in nutrition and so hard to digest that he might as well be eating the mud. He is surrounded by 1 trillion tons of green, and he is dying of starvation. How do we know this isn't just a story? How do we know this is how it ended? Because the rocks tell us. The scientific evidence is brutal, silent, and absolute. In the rock layers before the rain, we find Dicinodon fossils everywhere. They are one of the most common fossils on Earth. Then you get to the line in the rock, the black shale, the Carnian Pluvial episode. And in the layers during and after that line, the Dicinodon fossils just stop. It's not a slow decline. It's an erasure. They vanish globally. The most successful large animal on the planet is gone. You are watching the end of an empire. It doesn't end with a bang, with a meteor, or a great, glorious battle against a new foe. It ends with a whimper. It ends with a confused, starving old bull, his legs trapped in the mud, trying to eat a pine needle, and not understanding why his world betrayed him. The specialists, the masters of the old, stable world, have no answer for this new, chaotic one. Their perfection, their 50 million years of evolutionary fine-tuning, was not a strength. It was a trap. And the trap has just snapped shut. The death of the Dicinodons, this slow, muddy, agonizing starvation, is not a quiet, isolated event. It is a trigger. You are watching a domino fall, and it's about to topple an entire, intricate line. The collapse of the primary consumers is now cascading, with terrifying speed, up the food chain. Before you even follow the predators, you spare a thought for the other herbivores, the rhynchosaurs. Remember them? The smaller, stranger creatures with the bizarre, shearing, fused-toothed jaws. They were the other great specialists living alongside the Dicinodons. If the Dicinodons, with their slightly more generalist, by comparison, beaks, were starving, the rhynchosaurs don't stand a chance. This is a key paleontological fact. Their jaws were even more specialized, fine-tuned to slice very specific roots and tubers from the seed fern family.
Their food isn't just unpalatable, it is gone. They can't eat the new ferns. They can't eat the conifers. They are, perhaps, the first to go. They starve even faster, vanishing from the world in a silent, muddy extinction. The fossil record for them just stops, a complete and total dead end. And now the pyramid itself collapses. You are back in the dark, wet conifer forest. The air stinks of rot and mildew. The sound of the rain is a constant, deafening roar. And you are stalking a Postosuchus. This is the king, the apex predator, the Rawisuchian. It is by all measures the most powerful and terrifying creature on the continent. It is healthy. It is strong. It is not sick. It is not struggling in the mud. Not yet. It is a perfectly honed 20-foot-long killing machine. And it is in trouble. It is hunting. It stalks through the dark, fern-choked undergrowth, its pillar-erect legs moving with a surprising, silent grace. It is looking for the herds. Its entire biology, its entire evolutionary purpose, is to find the great, slow-moving buffets of placerias. It is driven by an instinct carved over millions of years. Find the herd. Kill the weak one. It finds nothing. It finds the smell of them, but it's the wrong smell. It's the smell of rot. It finds the bones of a Dicinodon already sinking into the black, fungal mud. But there is no meat left. There is no herd. This is a new, existential terror for the predator. What happens when the prey vanishes? The Postosuchus is an engine that has just run out of fuel. It is powerful, yes, but its power is dependent on the Dicinodons. The herds have vanished. The Rawisuchians, the top of that simple, brutal, three-tiered pyramid, are now standing on a foundation of air. And so, the king begins to starve. But here is the great, open, scholarly debate among paleontologists. Did they just starve? Was it that simple? A simple, tragic A causes B cascade? Or was it more complex? Here is the quirky and perhaps more terrifying tidbit. What if the world itself, the new landscape, became the true predator? Think about it. What was the Postosuchus built for? It was an open plains hunter. Its powerful, pillar-erect legs were for covering distance, for ambushing or perhaps even running down a Dicinodon in the sparse, open, seed fern scrubland. Its entire hunting style was based on a world of open horizons and firm, red earth. Now look at the world you're in. It is a dark, cluttered, choked forest. The ground is a deep, grasping, unstable bog. The open plains are gone, replaced by a maze of new, raging rivers and deep, muddy valleys. This new world isn't just empty for the Postosuchus. It is hostile to its very design. It can't hunt here. It can't move. It can't see more than 20 meters through the dense, wet gloom and fern-choked undergrowth. Its specialization, its open plains hunting kit, is now useless. It's like a Formula One car trying to win a race in a swamp. So the king dies a pathetic death. It is starving, yes, because its food is gone. But it is also trapped. It is an apex predator, undone not by a rival but by botany and mud. The scientific evidence is the same, silent, brutal story. Just like the Dicinodons, the Rawisuchian fossils, Postosuchus and all its kin, vanish. The entire dominant lineage of apex predators is erased from the fossil record, right at the same black line. The old kings are dead. The Dicinodons, the specialists of the low plains flora, gone. The Rhinchosaurs, the specialists of the roots and tubers, gone. The Rauisuchians, the specialists that hunted them, gone. The rulers of the Triassic, the masters of the arid, stable, seed fern world, have been completely and totally filtered out by 2 million years of rain. You are now standing in an empty world, a world of opportunity. The throne is vacant. You are standing in a world of ghosts. The rain is still falling, a constant, deafening roar. The air still stinks of rot and fungus, but the characters are gone. The great thundering herds of Dicinodons are a memory. The terrifying silent stalk of the Postosuchus is a story you can no longer tell. The world is empty. This is the most critical concept to understand. This is the great filter. This is a mainstream concept in paleontology and evolutionary biology. The Carnian Pluvial episode was not a dumb apocalypse. It wasn't an asteroid or a gamma-ray burst that just killed 90% of everything, indiscriminately. If it had been, the survivors would have just been smaller versions of the old kings. The Dicinodons and Rauisuchians would have just bounced back. But this was a smart apocalypse. It was a test. It was a filter. It didn't just kill. It selectively removed. It was a test with one very specific question. Are you, in any way, specialized for a dry, stable, seed fern-based ecosystem? And the old kings, the Dicinodons and Rauisuchians, confidently raised their hands and said, "Yes, we are the most specialized. We have perfected it." And the rain said, "Congratulations. You fail. You are filtered." The rain, the mud, the new flora, it was a custom-made weapon designed to erase the specialists. It was a filter that only let a very specific type of organism pass through. So, what is left? Who made it through the filter? You look around the muddy, conifer-choked wasteland, and you see the survivors. And here is the great, quirky, and deeply ironic tidbit of this entire story. The survivors are the unspecials. They are the boring ones, the generalists, the creatures that had failed to win the old world, the ones who had been living in the margins, the ones nobody cared about, the ones who were just there. The creatures that weren't good enough to specialize. Their failure in the old world became their survival strategy for the new one. They survived because they weren't specialized to eat seed ferns. They were eating whatever. Bugs, grubs, slimy ferns, carrion. They survived because they weren't specialized for open plains. They were already used to hiding in the shadows, in the cracks, in the undergrowth. They survived because they weren't the top predators. They were the prey. And prey knows how to hide. This catastrophic 2-million-year-long reset button has just wiped the slate clean. The throne of Pangea is now empty, and the world is suddenly, desperately, full of job openings. The world is full of vacant niches. The scientific evidence for this is the subsequent radiation, the explosion of new life forms. But right now, in this moment, it's just empty. There is a planetary help wanted sign. Wanted, large herbivore. Must be able to eat tough resinous conifers and ferns. Must be able to walk on mud. The position formerly held by the Dicinodon dynasty is now open. Wanted, large land predator. Must be able to hunt in dark, wet, cluttered forests. The position formerly held by the Rauisuchian Empire is now open. The entire ecosystem is a power vacuum. The game of who rules the world is starting over, from scratch. And this is the great open scholarly debate in all of paleontology. For decades, people asked, why did the dinosaurs take over? What made them so special? What made them better? And the Carnian Pluvial episode, this great, wet, fungal stinking filter, provides a stunning, humbling answer. What if they weren't better? What if they were just lucky? What if the dinosaurs didn't win the Triassic? What if they just showed up for work the next day, looked around, and found that all their bosses and all their competition had been filtered? The game is not to the strong. The game is to the survivor. And now, for the first time, we turn our full attention to those survivors. We look into the shadows, into the mud, and at the creatures who made it through the filter. You are standing in this empty, grieving world, a world scoured of its kings. You've been looking for the new rulers, looking for the next large thing, but you've been looking in the wrong place. The answer isn't on the empty throne. The answer is in the shadows. The answer is in the mud. You look down. You part the slimy, dripping ferns that are choking the forest floor. You look beneath the rotting log of a fallen conifer, the one that is covered in a carpet of fungal slime, and you see it, a flicker of movement. It's not a monster. It's not a king. It's a tiny, trembling, whiskered creature, no bigger than your hand. Its fur, which is already a new evolutionary invention, is matted and soaked in the endless, miserable rain. Its black, beady eyes are wide with what looks like permanent, existential terror. It is a mammalomorph, a proto-mammal. It is, in the most profound and humbling way possible, our ancestor. This is a survivor. This tiny, terrified, seemingly insignificant creature made it through the filter. The 2-million-year-long apocalypse that erased the hippo-sized, tusked, tank-like Dicinodons. This little shrew survived it. How? The answer is as simple as it is beautiful. It survived by being the exact polar opposite of a Dicinodon in every conceivable way. The Dicinodon was huge. It was an engine that required a mountain of food. This mammalomorph is tiny. It can survive for a week on a single handful of grubs. Its metabolic needs are microscopic. The Dicinodon was a specialist. It was perfectly tuned to eat one thing, and when that one thing vanished, it starved. This mammalomorph is the ultimate generalist. It eats anything. And in this new, rotting world, anything is the only thing on the menu. Here is the quirky and crucial tidbit. The world of rot you're in, the fungal spike, the endless decomposing seed ferns and the new moldy conifers. This isn't a graveyard for our ancestor. It's a buffet. This is a world exploding with its favorite food. It's a plague of insects. The rot is feeding trillions of beetles, grubs, worms, and millipedes. Our ancestor isn't starving. It is feasting on the decomposers that are feasting on the dead world. But its greatest survival tool was not its diet. It was its behavior. The Dicinodon lived its life out in the open, on the firm, red plains. It had no defense against the new world, no off switch. Our ancestor hides. You watch as the trembling creature darts from the rotting log and scrambles to a small, hidden hole in the muddy bank. It vanishes. It has gone. Underground. This is the secret. It lived in a burrow. while the world above was a chaotic, sensory hell, a deafening 100-decibel roar of thunder and rain, a world of liquid mud and falling trees. Our ancestor was safe. It was dry. It was quiet. It was in a custom-made microclimate, a tiny, dark, warm pocket of normal that it built for itself. It simply opted out of the apocalypse. This is the mainstream historical fact, the great origin story of the mammals. The Carnian Pluvial episode and the subsequent 150 million years of dinosaur rule is why we became what we are. We doubled down on being small. We doubled down on being nocturnal, on hiding from the day world which was now ruled by monsters. We doubled down on being secretive, generalist, burrow-dwelling survivors. We survived the chaos by refusing to participate. The scientific evidence for this is clear. The mammalomorph and early mammal fossils persist. They walk right across the extinction boundary, their tiny teeth and jawbones showing up in the rocks before, during, and after the Dicinodons vanish. They were the great hiders of life. And paleontologists still debate the consequences of this choice. Was this 150 million year-long age of hiding a prison, locking us into a small, nocturnal form while the dinosaurs ruled? Or was it a forge, a crucible that forced us to develop the very traits that would make us? Us. Warm blood, hyper-efficient hearing and smell. For the night, and complex big brains to outthink our predators. You look at that burrow entrance, a tiny, dark, insignificant hole in the mud. It is not impressive. It is not a throne. Its inhabitant is not a ruler, but it is a survivor. And it will wait. It and its descendants will wait in the shadows, in the burrows, under the feet of the new kings, for another 150 million years, for their throne to finally become vacant. You've seen the hiders, our tiny, terrified ancestors who survived the apocalypse by opting out, by vanishing into the mud. Theirs is a story of quiet, patient endurance. But they were not the only survivors, and not all the survivors hid. The rain, you see, was only a catastrophe from one perspective. From the point of view of a Dicinodon, a creature of the dry, firm earth, this endless 2-million-year-long deluge was a punishment. It was a world-ending nightmare. But for other lineages, this wasn't a punishment. This wasn't a flood. It was an invitation. This deluge, which drowned the old kings, was an opportunity. It was the creation of a new, vast and fabulously wealthy habitat. You're standing on the bank of one of those new, raging, kilometer-wide rivers. It's a muddy, turbulent, terrifying torrent. But you look closer, past the churning brown water. The river is teeming with life. The old arid world had only ephemeral ghost rivers. This new wet world has created millions of square kilometers of permanent, deep, powerful waterways. It's a brand new niche, a job opening that never existed before. And that job has just been filled. You see a pair of nostrils, 2 small bumps, break the surface of the muddy water. They move with a silent, confident grace, cutting a V-shaped wake through the current. Then, just as silently, they vanish. A moment later, there is an explosive thrash of water nearby as a huge, lungfish-like creature is snapped up from below. A new king has been crowned, not a king of the land, but a king of the water. You see it now, basking on a rare, muddy sandbar. It looks familiar. It looks for all the world exactly like a modern crocodile. It has a long, tooth-filled snout. It has armored plates, scutes on its back. It has a powerful, flattened tail and short, splayed-out legs. It is the perfect, terrifying, aquatic ambush predator. But here is the mainstream historical fact, one of the greatest gotchas in all of paleontology. This is not a crocodile. It is a phytosaur. It's from a completely different lineage of reptile. Its crocodile appearance is one of the most classic and most stunning examples of convergent evolution in the fossil record. Convergent evolution is the process where two unrelated creatures, faced with the same environmental problem, independently evolve the same solution. The problem was, how do you become the apex predator of a muddy, murky river? The solution was long, sensitive snout, eyes and nostrils on top of your head, so you can hide underwater, armored back, and a powerful tail. The phytosaurs solved this problem first, evolving a toolkit so perfect that 100 million years later, the actual crocodiles would evolve the exact same one. And here's the quirky anatomical tidbit that gives them away. Their nostrils. A true crocodile has its nostrils at the very tip of its snout. A phytosaur has its nostrils way up by its eyes. The Carnian Pluvial episode didn't just help the phytosaurs, it created them. The scientific evidence is in the rocks. Their fossils are rare before the CPE. Then, in the rock layers of the CPE, in these new, thick, river-channel deposits, their fossils are everywhere. They exploded in diversity. They became the new apex predators of this new, watery world. The rain that was a curse on the Dicinodons was a blessing for them. And they're not alone. You see something else moving on the muddy bank? A strange, slow-moving creature, covered in an armored dome, pulls itself from the water. This is the other great winner. Here is a truly bizarre, quirky fact. The first true turtles appear, suddenly, in the fossil record at almost this exact same time. Their lifestyle, their very design, is a perfect strategy for a world like this. Think about it. It's a world of constant, violent rain, of deep, unstable mud, and of new, terrifying predators, the phytosaurs. What's the turtle's solution? 1. It's semi-aquatic. It doesn't care if the world is a swamp. It's supposed to be a swamp. 2. It has a house. It has a bunker. It carries its own burrow on its back. It is the ultimate hider that doesn't need to hide. It can just stop. And here is the great, open, scholarly debate. Where on earth did turtles come from? Their origin is one of the deepest mysteries in paleontology. They just show up in the fossil record, fully formed, shell and all, right around this chaotic period. Did the pressure of this new, wet, dangerous world cause their rapid evolution? Was the shell a sudden, revolutionary answer to the phytosaur problem? Or were they just another lucky lineage, evolving their shell for other reasons, and then suddenly finding themselves in a world that was perfectly suited to their weird, new toolkit? We may never know, but the result is clear. You look at this new world. The land is a muddy, chaotic, dangerous, empty place. But the water is a thriving, stable, full ecosystem. The phytosaurs have taken the water throne. The turtles have mastered water defense. The crocodilian ancestors are also diversifying, finding their own paths in the new swamps. These groups, the watersiders, they didn't just survive the CPE, they were forged by it. They chose the water. They have partitioned the new world. They have, in a sense, seeded the land, which leaves the land, that vast, empty, muddy, conifer-choked terrestrial throne, completely and totally vacant. It is waiting for the other survivors. It is waiting for the ones who didn't hide and didn't swim. It's waiting for the lucky ones. You've seen the survivors. You've seen the story of the hiders, our tiny, terrified, burrowing ancestors, who passed through the apocalypse by simply refusing to participate. Theirs is a story of patience, a 150 million year-long game of wait. You've seen the swimmers, the phytosaurs, the turtles, the crocodilian ancestors. They saw the flood not as a curse, but as an invitation. They chose the water, a new, rich, stable habitat, and built a new dynasty there, seeding the land. And now you look at the land itself, that vast, empty, muddy, conifer-choked terrestrial throne. It is vacant. The hiders are under it. The swimmers are around it. But who is left to claim it? And finally, you see them. The third group of survivors. A small, bipedal creature darts from the shadow of one giant, dripping fern to another. It moves with a quick, bird-like, nervous energy. You recognize it, or at least you remember the type. It's a dinosaur. Remember them? From Section 5? The creatures you almost missed? The small, turkey-said, chicken-seized nobodies that were scurrying in the shadows, just trying not to get stepped on by the Dicinodons or eaten by the Rauisuchians. The ones that were so rare, so ecologically irrelevant, that they were barely a footnote in the old world. They're still here. This right here, is the central mystery. This is the question that haunted paleontology for a century. Why? How did the hippo-sized, tusked, tank-like Dicinodons, the most successful animals on Earth, get erased, while this two-legged, 20-pound pipsqueak survived? How did the 20-foot-long apex predator Postosuchus get filtered, while this thing just walked right on through? The answer is the very reason they were nobodies in the first place. The answer is that they were lucky. You watch the creature. It stops, pecks at the ground, and pulls up a long, wiggling beetle grub from the rotting wood. It swallows it whole. Here is the first and most important clue. They were not specialists. The Dicinodon was a fine dining specialist whose restaurant, the seed fern, had just been demolished. This dinosaur is a dumpster diver. It's a generalist. Its entire survival strategy in the old world was eat whatever you can find and don't be picky. And in this new, chaotic, rotting world, whatever is the only thing on the menu. They ate the bugs and grubs that were feasting on the fungal spike. They ate the lizards and other small vertebrates that were also generalist survivors. They ate the carrion of the dying Dicinodons, plenty of that. They probably even ate the slimy, poisonous ferns that the Dicinodons couldn't touch, their non-specialized guts just coping, extracting just enough calories to keep going. Their non-specialized diet, the very thing that made them B-team competitors in the old world, was the exact survival kit they needed for the new one. They were pre-adapted for a world where the only food is garbage. Then you watch it move. It darts across a patch of the deep, sucking, unstable mud that killed the Dicinodons. And it doesn't struggle. It moves with a light, easy, two-legged gait. This is the second critical mainstream fact: their stance. Dinosaurs, even these early ones, had a fully erect pillar stance. Their legs were under their bodies like a bird's, not sprawling out to the sides like a lizard's. And here is the quirky and utterly critical tidbit for this world. This made them masters of the mud. Think about it. A Dicinodon, with its semi-sprawling hippo-like build, has to push its heavy, low-slung belly up and out of the grasping mud with every single step. It's an exhausting, inefficient, losing battle. This bipedal dinosaur, it's a mud walker. It's light on its feet. Its center of gravity is high. Its legs are just pillars punching down and up. It is simply, from a purely biomechanical point of view, more efficient at moving over this new, terrible, unstable, liquid landscape. The scientific evidence is the fossil record itself. The Postosuchus fossils stop at the black line. The Placeria's fossils stop. The dinosaur fossils do not. They are found in the exact same rock layers as the phytosaurs, the turtles, and the mammalomorphs. They persist. They walk right across the extinction boundary, their rarity in the old world simply becoming survivorship in the new one. This is the humbling answer. They weren't better. They weren't stronger or smarter. They were just lucky. They were pre-adapted for chaos. And paleontologists still fiercely debate this very point. Was it truly just lucky timing? Or was there some other hidden dinosaurian superiority? A more efficient, bird-like lung, or a higher metabolism? That gave them the edge. But the simplest answer is the one you are seeing. They survived because they ate garbage and walked weird. Their B-team traits, the ones that made them losers in the stable, old world, were the exact winning lottery numbers for this new, wet, chaotic, fungal-choked hellscape. They made it. They passed the filter. And now you watch that little dinosaur, that survivor, as it hops onto a fallen, moss-covered conifer. It straightens up. It looks out over the grey, empty, dripping, silent world. A world with no large predators. A world with no large herbivores. A world that is, for the first time, theirs for the taking. You are standing in that new, empty world. You are watching that small, lucky dinosaur look out over its new, vacant kingdom. And you are waiting for the other shoe to drop. You are waiting for the next catastrophe. But it doesn't come. Instead, something even more profound happens. After a span of time you simply cannot comprehend. 2 million years. 2 million years of the endless, deafening, world-drowning roar. It stops. It doesn't stop all at once. It's not a switch, but it's a fade. The wetter seasons become less wet. The wet seasons become shorter. The constant drum roll of thunder in the distance. One day you realize you haven't heard it for a week. The oppressive, lead-grey, 100% humidity ceiling begins to thin. You see a patch of sky that is a slightly lighter shade of grey. And then, after 1,000 years of this fading, a true dry season returns. Why? What has changed? You have to go back. You have to travel all the way back to that fiery western coast of Pangea. You have to go back to the Wrangellia eruptions. Those fissures, those curtains of fire that were pumping the CO2 into the sky. They are sputtering. This is a key mainstream geological fact. Large igneous provinces, as large as they are not eternal. The tectonic plate, in its slow, grinding continental drift, has moved. The patch of crust that was hot has been slowly, inexorably dragged off the deep mantle plume that was fueling it. The fissures are being sealed up by their own cooling lava. The magma chambers, after hundreds of thousands of years of eruption, are finally exhausted. The great planetary engine of the apocalypse is running out of fuel. The exhaust pipe that was pumping billions of tons of CO2 into the sky sputters and dies. The fuel of new CO2 has been cut off. And now, for the first time in 2 million years, the planet's natural systems, its janitors, can finally start to clean up the mess. And the planet has a brand new, powerful janitor that it didn't have before. The conifer forests. Those vast, dark, new forests that took over the world. They are thirsty for carbon. They are breathing in that CO2, using it to build their woody, resinous trunks. The new living world is, itself, a carbon sink. The oceans, though poisoned and muddy, are also slowly absorbing the CO2, locking it away as limestone on the deep seabed. Slowly, painstakingly, the excess carbon is being drawn down from the atmosphere. And as the CO2 levels fall, the feedback loop breaks. The runaway cycle, more heat, more evaporation, more water vapor, more heat, stops. The air begins to hold less moisture. The planet's fever begins to cool, just a few degrees. The hydrological cycle, which had been a raging, screaming, meth-fueled maniac, calms down. It returns to a normal state. The sky clears. The scientific evidence for this is as clear as the evidence for its beginning. In the rock record, that thick, dark, black shale layer just ends. And right on top of it, a cap, you find new layers. You find different layers, layers of rock that speak of drier conditions. The wet world is over. And paleoclimatologists still debate how fast this drying was. Was it as fast and catastrophic as the wetting that started it all? Or was it a long, slow, million-year-long drying out phase, a gradual return to a new kind of normal? Here's a quirky sensory tidbit. What you notice after a lifetime of smelling only rot and fungus and mildew is a new smell. The ground for the first time is dry. And the next time a normal rain shower passes, you smell it. Petrichor. That true, clean, electric smell of water hitting dry earth. It's a scent that no living creature on earth has smelled for 2 million years. It is the smell of a new old memory, the smell of a normal world returning. But you have to understand, the world dries out. The great continent-spanning bogs and swamps recede. The ephemeral rivers return to being seasonal. But it is not the same world. It is not the red, arid, seed fern-covered Pangea of the old kings. The old kings are gone. The seed ferns are gone. The soil is gone, washed into the sea. This is a new world, a changed world. It is a new normal. And it is a normal that has been built by the survivors. You are standing in the early Jurassic. The year is perhaps 200 million BCE. The Carnian Pluvial episode is over. It is a fading memory. It is a story, a dark legend that is now just a scar, a layer of black, oily shale and coal buried deep beneath your feet. The 2 million year-long, sanity-shredding roar of the rain is gone. The silence that follows is profound. It is the first true silence the planet has known in an age. And you are standing on the result. You are standing in the new normal. You look out, and you must ask the question, what does the world look like? First, you must erase the old image. The red world is gone. The vast, open, rust-colored plains of the dicroidium seed ferns, they are extinct. They never came back. That entire arid, adapted ecosystem was not just paused, it was deleted. Second, you must erase the intermediate image. The grey, muddy, fungal-choked, liquid hellscape of the rain, that is also gone. The mud has settled. The water has cleared. The constant, suffocating 100% humidity has broken. What is left is a new world. A green world. You are standing in a forest that stretches from horizon to horizon. But it is not a forest you would recognize. There are no flowers. There are no broadleaf trees, no maples, no oaks. There is no grass beneath your feet. You are standing in the age of conifers. This is the single greatest paleo-botanical fact of the new era. The opportunists who won the CPE, the conifers, their victory was total. They stayed. They inherited the earth. You are in a world dominated by the ancestors of modern redwoods, araucaria, monkey puzzle trees, and pines. It's a world that is visually, texturally, and sensorily different. The smell of the old world was dry dust and rock. The smell of the flood was rot and fungus. The smell of this new world is resin. It's the sharp, clean, antiseptic pine smell. The air is thick with it. It's a pine sol world, a global forest of it. The trees constantly bleeding this sticky, protective sap. Here's a quirky tidbit. This massive global production of resin is why the Jurassic period, which you are now entering, is a gold mine for amber, trapping insects, feathers, and the story of this new world. The geography is also new. Remember those monster rivers, those canyon-carving torrents? The engine of the flood is gone, but the plumbing remains. The scientific evidence is in the rocks, the vast, established, mature river systems that now cross the land are a permanent legacy of the flood. The CPE was the violent first cut. Now these are just huge, calm, permanent rivers flowing in the channels that the apocalypse carved for them. The world is now a wetter place than the old, arid Pangea. But it is a stable wet, a world of vast lakes and meandering, powerful rivers. The climate is still a hothouse. It's a key mainstream fact that the entire Mesozoic was, on average, far warmer than our world. There are still no polar ice caps, but the insane, runaway humidity is gone. The climate has stabilized. It's a warm, damp, but reliable greenhouse, and paleobotanists still debate the true feel of this new world. When you look at this conifer forest, what do you see? Was it the black forest of our imagination? A dense, dark, gloomy, close-canopied world where light never touched the ground? A world of permanent, dripping shade? Or, as other evidence suggests, was it a more open world? A conifer parkland? Or savanna, with vast open spaces between the great, towering trees? The answer is probably both. But the key is that the foundation has been laid. The stage set for the next 150 million years is built. And the scientific evidence for this is, again, the pollen record. You look in the rocks, above the black shale. The seed fern pollen never comes back. It is gone. Forever. The layers above are, and will remain, dominated by conifer pollen. The takeover was permanent. You stand in this new, quiet, resin-scented forest. The silence is different. The old, arid world had the sound of wind. The flooded world had the roar of rain. This world is quiet, but it is not silent. The silence of the old kings, the thudding, grazing herds of Dicinodons, the stalking of the Rauisuchians, that is a true silence, an absence. But there is a new sound, a sound the planet has never heard before. It's a heavy sound. It's the creak of a multi-ton tree sapling being pulled and snapped. It is the thud, the heavy, rhythmic, earth-shaking thud. It is the sound of footsteps, the heavy footsteps of new and very, very large giants. You're hearing those new, heavy footsteps. The dinosaurs, those lucky survivors, are no longer small, turkey-sized pipsqueaks. In the millions of years since the rain stopped, they have exploded. This is the dinosaur radiation, the great, formal taking of the throne. The help-wanted signs have been answered. But the old question, the one that haunted paleontologists for a century, still hangs in the resin-scented air. Why them? Okay, so they were lucky. They were generalists who survived the filter. We've established that. Their garbage-eating, mud-walking traits got them a ticket to the new world. But that just explains their survival. It doesn't explain their dominance. Why, in this new, empty world, did they become the 100-ton giants and not our ancestors? Why didn't the mammalomorphs, the hiders, immediately come out of their burrows and radiate into the forms of hippo-sized mammals and tiger-sized mammals? They were survivors too, right? Why did they stay small, secretive, and nocturnal for the next 150 million years? What did the dinosaurs have that our ancestors didn't? The answer is terrifying. The answer is that their luck wasn't just passive. Their B-team survival kit, the one they had all along, contained a secret weapon, a biological superpower. And here is the great, open, scholarly debate that has defined modern paleontology. That superpower, the one that allowed them to truly conquer the new world, was their lungs. It sounds boring, doesn't it? Lungs, not claws or teeth, but this is the key. You, me, and our tiny, shrew-like mammalomorph ancestor. We all use a bellows lung. This is a key mainstream biological fact. We breathe in, the air goes into a bag. Our lungs, it mixes, we absorb the oxygen, and then we breathe the same, stale air back out through the same tube. It's a two-way street. It's inefficient. You're always mixing fresh air with used air. The dinosaur, you watch it breathe. It doesn't. Not like you do. It has bird lungs. This is not a guess. The scientific evidence is in their bones. When we look at the fossils of theropods, like T-Rex, and sauropods, the long necks, their vertebrae are not solid. They are full of holes. They are pneumatic. For decades we thought this was just to save weight. But we now know those holes were for air sacs. Dinosaurs, and modern birds, their descendants, have a hyper-efficient, one-way, flow-through respiratory system. When they breathe in, the air doesn't just go to their lungs. It goes to a set of posterior air sacs. When they breathe out, that fresh air is blasted from the sacs, through the lungs. When they breathe in again, that used air is sucked out of the lungs and into an anterior set of air sacs. When they breathe out again, that stale air is finally expelled. Do you see what this means? It's a 4-stroke engine. Air is always moving in one direction across the lung. There is no mixing of fresh and stale air. It is unbelievably efficient at extracting oxygen. Here's the quirky, mind-bending tidbit. A bird, or a dinosaur, can extract 3 times as much oxygen from a single breath as a mammal can. Now, look at the world you are in. You are in the early Jurassic. The planet's climate just spent 2 million years being poisoned, rewritten, and flooded by a CO2-pumping volcanic event. And here is the great, debated environmental fact. The atmosphere of this new world was not our atmosphere. It may have been a world of fluctuating or low oxygen, or a world still burdened with high CO2. It was a tough atmosphere to breathe. And in that tough, hypoxic, high CO2 world, our mammalomorph ancestor, with its inefficient bellows lung, comes out of its burrow. It takes a few breaths. It gets gassed. It's exhausted. It can't be active. It can't run. It can't grow. It is physiologically imprisoned by the air itself. It is forced to stay small, low energy, and hide in its oxygen-rich burrow. The dinosaur, with its bird-lung superpower, takes a breath, and it thrives. It has a massive physiological advantage. It can run harder. It can run longer. It can grow to enormous sizes because its engine is simply better. This lung, this flow-through system, was their secret. It was the lucky adaptation, evolved for reasons we don't understand, that suddenly became the key to the kingdom. It was the biological superpower that allowed them to be more active, to fuel a higher metabolism, and to scale up, while our ancestors were left gasping in the dust. That bird lung was the engine, the superpower that let them thrive in the new, tough atmosphere. But a powerful engine is useless if it's attached to a terrible chassis. And this is the second great advantage. The dinosaurs didn't just have better lungs, they had better legs. You're watching one of the new mid-sized dinosaurs, an ancestor of the great longnecks, moving through the conifer parkland. And you're struck by its gait. It moves with an effortless, efficient fluidity. Its legs are not splayed out to the side, like a lizard's, forcing it to waddle and push its body from side to side. Its legs are directly underneath its body. This is the mainstream anatomical fact, the pillar erect stance. Their legs are like columns, supporting their weight from below. This is a massive advantage in physics. A lizard, with its sprawling legs, has to spend energy just to hold its belly off the ground. A dinosaur just stands. All its energy can be dedicated to moving forward. And you have to contrast this with the other survivors. Our mammalomorph ancestor, with its sprawling or semi-sprawling gait, is still a small, low-energy waddler. It can't run for a kilometer. It's not built for that. It's built for scrambling and hiding. This pillar-erect stance makes the dinosaur hyper-efficient. It's the long-distance runner build. And now, look at the world it's in. It is in a vast, empty Pangea. The conifer forests and fern prairies stretch for thousands of uninterrupted kilometers. This is a world where the primary challenge is no longer hiding from Postosuchus. The new challenge is, how do you find the next patch of food? In this new, empty, resource-scarce world, the ability to move efficiently for long, long distances, That is the key to colonizing new territory. The dinosaurs, with their super lungs fueling their super legs, are the only creatures that can do it. They are the great colonizers of this empty planet. And here's the quirky anatomical tidbit. This dinosaur hip is a true marvel of evolutionary engineering. It's not just that the legs are under the body. The socket of the hip itself, the acetabulum, is a hole. It's an open, cupless socket that let the head of the femur, the thigh bone, lock into a vertical load-bearing position. It was a simple, revolutionary piece of biological engineering that made them born to walk and to run and to get big. But there's a third advantage, and it's the one that lets them lock in their victory. The dinosaur you are watching is growing. It is growing fast. The scientific evidence for this is one of the most brilliant discoveries of modern paleontology. We can read their bones. Just like a tree, a dinosaur's bones have growth rings in them. When we slice a fossilized bone, put it under a microscope, we can see how it grew. And what we see is stunning. The bone is not the slow-growing, cold-blooded bone of a modern reptile, which might take 50 years to get to a large size. The bone is fibrolamellar bone. It is the fast-growing, hot-blooded bone of a modern bird or a mammal. It is a bone that is riddled with blood vessels, a scaffolding that is being built in a hurry. This is the final piece of the puzzle. Dinosaurs didn't just survive. They didn't just move efficiently. They grew like weeds. A giant sauropod, the longnecks, could go from a 10-pound hatchling to a 20-ton adolescent in just 10 to 15 years. A modern crocodile might take a century to get to a fraction of that size. This rapid growth is the conqueror's ultimate weapon. Why? 1. It allows you to outcompete everyone. You are bigger than the surviving reptiles. Faster. 2. It allows you to recover your population. You can breed faster, reach sexual maturity in years instead of decades, and bounce back from any local disaster. 3. It allows you to get bigger, faster. You are in an evolutionary arms race with yourself. The herbivores get big, so the predators get big to hunt them. And they can do it, because their biology supports this rapid scaling. Our mammal-like ancestor, it also grew relatively fast. But its chassis, its lungs, it was physiologically locked at a small size. The dinosaur had no such limits. This is the great tragic what if of the Jurassic. The dinosaurs were not just lucky survivors. The filter of the CPE happened to select for a creature that was a monster in waiting. Their generalist survivor kit, the bird lung, the pillar legs, the fast growth, this wasn't a survivor's toolkit at all. It was a conqueror's toolkit. The apocalypse had just by pure dumb luck handed the keys to the kingdom, to the only creatures on Earth that were biologically capable of becoming giants. You are standing in this new, green, conifer world, and you are witnessing the dinosaur explosion. This is the radiation. The lucky survivors, armed with their secret weapons, the bird lung, the pillar legs, the fast growth, are now claiming their inheritance. The empty world is being filled, and it's being filled by them. The first job to be filled is the most obvious one. The large herbivore position, left vacant by the tragic muddy starvation of the Dicinodons. For a few million years the world had no large plant-eaters, but now they are here. You hear that sound? The heavy rhythmic thud. You see the source. It is not a Dicinodon. It is something new. It is a sauropodomorph. This is the ancestor of the great long necks, the Brachiosaurus and Diplodocus of your childhood imagination. This one, perhaps a Plateosaurus or a Lufengosaurus, is not yet 100 tons. It's only the size of a large elephant, and it can still walk on 2 legs or 4. But it is the answer to the vacant throne. It is the new large herbivore, and it has a new tool. A tool that no Dicinodon ever had, and no mammal would ever perfect to this degree. It has a long neck. This seems like a simple, obvious invention, but you must understand, it is a revolutionary one. Why? Because the world has changed. Remember the old seed fern world? It was a low world, a shrubland. The Dicinodons were low browsers, built like hippos. But the new world, the world created by the rain, is a tall world. It is a world of conifers, of 30, 40, 50-foot tall trees. The food is no longer at your feet. It is up. The sauropodomorph, with its long neck, is the only creature on Earth that has an access pass to this new, vast, untapped buffet. It can just stand there, its efficient pillar legs planted and graze the treetops, while our tiny mammalomorph ancestors are scurrying, starving, in the leaf litter 30 feet below. This is the single most beautiful mainstream historical fact of this new age. The Carnian Pluvial episode created the conifer forests, and the conifer forests, in turn, created the long-necked sauropods. The environment itself, the problem of a tall forest, demanded a long-necked solution. The dinosaurs were the only ones whose chassis, the bird lung, the light, hollow-boned vertebrae, allowed them to evolve that solution. You can't evolve a 30-foot long neck if you have a heavy, solid skeleton and an inefficient bellows lung. You'd suffocate and your neck would collapse. The dinosaurs were the only ones who could, and so they did. But a world full of new, giant walking buffets creates a second job opening. The other vacant throne, the large land predator, the position left open by the Postosuchus. And as the sauropodomorphs get bigger, their predators get bigger too. You see one. It's a theropod. The same lineage as that turkey-sized pipsqueak from before. But it's not a turkey anymore. It's a coelophysis or a Dilophosaurus. It's 20 feet long. It's fast. It's a 2-legged, hyper-efficient killing machine, armed with its super lungs, its super legs, and a mouthful of steak knives. Here's a quirky, terrifying tidbit. The theropod's lightness was their greatest weapon. Their bones were hollow. They were just struts. They were, pound for pound, lighter and faster than any predator the world had ever seen. And now the true age of dinosaurs begins. It is not an age of static, boring monsters. It is a dynamic age. It is a 150-million-year-long evolutionary arms race. This is the great open scholarly debate. What drove this arms race? Was it the plants? As conifers got tougher and taller, the sauropods got bigger and longer-necked to eat them? Or was it the predators? As the sauropods got bigger, to be too big to hunt, the theropods got bigger, smarter, and started hunting in packs to take them down. The answer, of course, is yes. It's all of it. It's a complex, escalating spiral of move and countermove. Sauropodomorphs get bigger, so theropods get bigger. Theropods get bigger, so sauropodomorphs evolve even faster growth, or armor, or whiptails to defend themselves. It is this relentless, 150-million-year-long war that will sculpt the monsters you know. It is the engine that will turn these early prototypes into the Allosaurus and the Brachiosaurus of the Jurassic, and eventually into the T-Rex and the Triceratops of the Cretaceous. The Carnian Pluvial episode, that 2-million-year-long reign. It didn't just clear the stage. That's too simple. It set the stage. It killed the old cast. It built the new scenery, the conifer forests. And it handed the script to a new, lucky, and terrifyingly capable cast of actors. The reign didn't just start the age of dinosaurs. It wrote the first and most important act. You've been so focused on the land, on the new thundering footsteps of the sauropodomorphs and the theropods, that you've almost forgotten the other half of the world. You've forgotten the catastrophe that happened at sea. You look away from the resin-scented conifer forests and you turn your gaze back to the great oceans. What happened here? You are standing on the coast of the early Jurassic, and the first thing you notice is the color. The water is blue again. The siliciclastic switch, that 2-million-year-long blizzard of mud and silt that choked the world's reefs. It's over. The monster rivers, no longer fueled by a deluge, have calmed down. The mud has settled. The water is clear. And life is returning. You see new carbonate platforms beginning to grow. The great global reef ecosystem, the engine of the shallow seas, is slowly, painstakingly being rebuilt. But it's not being rebuilt by the same creatures. The old Triassic reef builders, the sponges and microbes, they are mostly gone. The siliciclastic switch did its job. It was a reset. The old kings of the sea were filtered out, just as surely as the Dicinodons were filtered on land. The old marine dynasties are gone. The old placodonts, the walrus-like, shell-eating reptiles, the nothosaurs, many of their lineages were severely pruned or erased by the CPE's muddy, anoxic, reef-killing waters. The throne of the ocean, just like the throne of the land, is vacant. And just like on land, this vast, new, empty ocean creates a power vacuum. And just like on land, that vacuum is about to be filled, not by the survivors of the old world, but by entirely new dynasties. This is the great mainstream historical fact of the post-CPE seas. This period, the end of the Triassic and the dawn of the Jurassic, is not just the age of dinosaurs. It is also the age of marine reptiles. As the dinosaurs were taking the land, a parallel and equally spectacular takeover was happening in the water. You are floating in the new, clear, warm waters. You see a shape. It's moving fast. It's a blur, moving with the speed and grace of a dolphin. But it's not a dolphin. It's an ichthyosaur. This is the fish lizard. It is one of the most extreme examples of convergent evolution. It is a reptile, a distant cousin of the dinosaurs, but it has re-evolved the exact body plan of a fish, and later a dolphin. A streamlined teardrop body, a powerful vertical tail fin, huge sensitive eyes for hunting in the deep. It is a living torpedo, a hyper-efficient air-breathing pursuit predator. And then, a shadow passes under you. A big shadow. You look down, and you see something else. Something impossible. You see a 40-foot-long neck, attached to a vast barrel-shaped body, being rowed through the water by 4 enormous wing-like flippers. This is a plesiosaur. This is the Loch Ness monster of the Jurassic. It is the other great solution to the marine predator problem. The ichthyosaur is the jet fighter solution. All speed. The plesiosaur is the attack helicopter solution. A long, flexible, search-and-destroy neck on a stable, powerful, paddling body. Here's the quirky, mind-bending tidbit. These two groups, the ichthyosaurs and plesiosaurs, are not closely related. They are two separate, parallel reptilian experiments in how to reconquer the sea, and they both become wildly successful at the exact same time in this new, empty, post-CPE ocean. The scientific evidence is, again, the fossil record. We see their fossils explode in diversity, distribution, and size in the early Jurassic rocks, the ones immediately following the Triassic reboot. They are the new apex predators. And of course, the great scholarly debate continues. Did the CPE cause their rise by killing all their Triassic competitors, thus clearing the board for them? Or were they just the next big thing anyway, and the CPE just accelerated their takeover? The timing is so perfect that it's hard to call it a coincidence. The mud-choked seas of the CPE filtered the old, shallow water specialists, and the new, clear, deep oceans of the Jurassic were the perfect hunting ground for these new, air-breathing, deep-diving giants. So you look at this new world. The entire biosphere, on land and in the water, has been rebooted. The 2-million-year-long reign was the Control plus Alt plus Delete for the entire planet. And now, 2 new parallel dynasties have inherited the Earth. The dinosaurs have taken the land. The marine reptiles have taken the sea. The Mesozoic era, the age of reptiles, has truly and formally begun. But how? How do we know any of this? You are now for a moment not a witness in the Triassic. You are a scientist. You are a geologist, and the year is 1985. You are standing in the Italian Alps, in the Dolomites, a place of stunning, sheer-walled mountains. And you are staring at a problem. You are looking at a cliff face of ancient Triassic rock, and you see the line. Down low, you see beautiful pale-colored limestone and dolomite, the carbonate rock. This is the fossilized remnant of a vast, thriving tropical reef, a warm, clear, shallow sea. And then, right on top of it, with the sharpness of a knife cut, you see a thick, dark, ugly band of black, oily shale and mudstone. The siliciclastic rock. And then, right on top of that, the pale reef limestone just comes back as if nothing ever happened. This is the mystery. This is the scar you saw at the very beginning. And for decades, geologists just noted it. It was an anomaly. A local flood, perhaps. A local tectonic event. It was weird, but it was just a thing. But then you start talking to your colleagues. A geologist in China says, That's bizarre. I'm looking at a Triassic cliff in Sichuan, and I have the exact same line. Black shale, right in the middle of everything. A geologist in Arizona says, Wait a minute. The Chinle Formation. It's full of black shales and coal beds, right on top of the arid Moenkopi red beds. It's the same story. A geologist in Argentina, a geologist in Australia, a geologist in Greenland, all see the same scar. This wasn't a local flood. This was a global something. This is the mainstream historical fact of the discovery. In the early 1990s, two British geologists, Michael Sims and Alastair Ruffle, finally put all the pieces together. They were the ones who formally proposed the Carnian Pluvial episode. They were the ones who had the courage to say, this wasn't a million different local events. This was one single planet-wide climatic catastrophe. They were the detectives who connected the dots. The dot of the black shales and the coal. The world's deserts turned into swamps. The dot of the siliciclastic switch. The reefs all over the world were choked and buried by mud at the same time. The dot of the pollen record. The global seed fern flora vanished at the same time and was replaced by a global conifer and fern flora. The dot of the fossils. The global Dicinodon and Rauisuchian dynasties vanished at the same time, and the global dinosaur, mammal, turtle, and phytosaur fossils suddenly radiated right after that same line. Sims and Ruffle laid out the what. This was the great murder mystery. They had the body. They had the time of death. They had the who. The dinosaurs took over. But they didn't at first have the murder weapon. And this is the final brilliant open scholarly debate. What caused it? The volcano idea was proposed, but it was just one of many. And then in the 2000s and 2010s, the geochemists came in. They were the forensics team. They were the ones who zapped the rocks with lasers. And they found the fingerprints. They were the ones who found the dot of the sharp negative carbon-13 excursion, the undeniable isotopic fingerprint of massive, mantle-derived volcanic CO2. And then they found the dot of the mercury spike, the other telltale fingerprint of a large igneous province eruption. And then they dated those fingerprints. And the date, 234 million years ago, matched perfectly with the known giant Wrangellia eruptions in western Pangea. The case was closed. This entire 2-million-year-long story, this tale of a drowned world, of starving kings and lucky bird-lunged survivors, it wasn't a story told by a person. It was a story assembled, piece by piece, over 40 years, by hundreds of patient, brilliant scientists. It is a story that was told, not in words, but in rock, in pollen, in atoms, and in bones. You are back in your own time. You are safe. You are dry. Perhaps you are in your bed, listening to the sound of a gentle rain tapping on your window, or the soft hum of a fan. The sounds of your world, a world that is stable and predictable and safe. And that sound, the tap, tap, tap on your window, seems so small now, so tame. Because you have, in your mind, just walked through a world that was broken by water. You have witnessed the Carnian Pluvial episode, and it is perhaps one of the most profound, most important, and least known turning points in the entire 4.5 billion-year history of this planet. It is a ghost story. It is a warning, written in a 2-million-year thick layer of black, oily rock. It's a warning that shows how interconnected everything is. It's a story that proves that the world is not a collection of separate things. It is one single, complex system. It is a story of how a geological event, the Wrangellia volcanoes, can trigger a chemical one, the CO2 spike, which triggers a climatic one, the runaway water vapor loop, which triggers a botanical one, the death of the seed ferns, which triggers a biological one, the mass extinction of the old kings, which finally triggers an evolutionary one, the radiation of the dinosaurs. It is a story that proves the world can and does change. Not just slowly, not just gradually, but violently and suddenly and catastrophically. And finally, it's a story that teaches us a humbling and perhaps terrifying lesson about what it means to win the game of evolution. It proves that the winners are not always the strongest, or the biggest, or the most specialized. The Dicinodons, they were the pinnacle of specialization. They were the masters, and their mastery was a trap. Sometimes the winners are just the survivors, the ones who are lucky, the generalists, the hiders, the ones who were pre-adapted for a chaos they never saw coming. The dinosaurs did not conquer the Earth. They did not win it in a fair fight. They were given it. They inherited the entire empty, silent, waiting planet by default. After a 2-million-year-long storm drowned the old rulers and washed the entire world clean. And so, our journey tonight comes to an end. The sound of the ancient, roaring rain finally fades, replaced by the soft, quiet hum of your own room. The world of the Triassic, of the black, muddy swamps and the dark, resin-scented conifer forests, dissolves and recedes, leaving you safe in the here and now. The ghosts of the Dicinodons and the Rauisuchians and the tiny, terrified mammals all return to their place in the deep, deep quiet of the past. You can let go of that ancient grey sky. You can release the tension, the feeling of the endless, clammy damp, and just feel the comfort of your own bed. The story is over. The mystery of the black scar is solved. It was a gravestone and a cradle, the end of one world, and the violent, noisy, soaking wet birth of the next, the age of dinosaurs. So now, there is nothing left to do but let your own world, the one that is safe and dry and warm, pull you down into sleep. Let your breathing slow. Let your mind grow heavy and soft. There are no monsters here. There is no rain. There is just the comfortable darkness and the promise of a quiet, peaceful night. The long, long age of the dinosaurs can wait for another day. For tonight, your own journey is done.